Okay, I'm recording now, so we can share this. The recording will be made available to all of you, also for Oliver's talk. Okay, yeah, Tim. Do you want slides? You've sent them to me? Yeah. Okay. By email? Okay. Sorry, it's been a long. Okay, I didn't see them. Okay, so we have slides. Share the desktop. And you can take it away. Okay. Should work without pushing. Okay.
Good morning, everyone. My name is Mr. Kwek from the University of Cape Town, and I'll be reporting back on our discussion about impact modeling studies and climate engineering. And thanks to Brendan and Jyoti for helping us to take notes. Basically, the idea was to look at what are the important variables that we need for impact modeling, then downscaling simulations, and then bias correction. And we had a different set of people from the impact modeling community in the group. We have people from hydrology, agriculture, health, and what other one again? At least we have different people from there and from different regions. So the first thing was to look at the variables and in terms of a time scale that we'll need. And then there are some of the variables that people mentioned. And some of them we have, but the major challenge is in the regards to time scale. Times of some want it at sub-daily, some want it to be daily, and then some towards the simulation output they want it at a particular time scale. Like I think Brendan to mention about some for his model, that it was I think maybe yearly output and he needed something for monthly output. So apart from the input variables, the ones that come out from model output in terms of CLM2, that subsequent simulation, they can save it for at monthly scale. And then in terms of some two at some pressure levels, people that want to look at something maybe with air quality. So those are part of things that we discussed yesterday. And then for hydrology, people were they're talking about stream flow data and surface runoff.
What about soil moisture? Did you discuss that?
No, I think we missed that. We didn't discuss that.
Have soil moisture.
See, that's what happens. You make all your leads, you run the simulations, and then what about this?
Okay, at least I asked now rather than after the runs.
That's a good.
Thanks, Alan, for that. So soil moisture noted. Then we talk about downscaling and bias correction. The two primary methods are both statistical and dynamical downscaling, and different discussion around it yesterday about what do we need in terms of the downscaling. The major challenge is the use of data set that people need in terms of downscaling. Different regions have different challenges with the data sets. The hydrology group, people from Southeast Asia, they've been able to work around it, but people in Africa, there's paucity of data to do something about the statistical downscaling. And the computational resources to do dynamical downscaling too is quite expensive. So a lot of back and forth on that, but we didn't really reach any conclusion. But the challenge is that the use of data set is very, very crucial. We want to do anything about downscaling and then see now the general group will be able to speak to that. And then for the stream flow data, which is very crucial for hydrology, there was an inquiry about how feasible it is for to downscale the stream flow data from GCMs. And with regards to GCM not suitable for doing comparison for regional process-based hydrological study that people may want to look at. And part of the questions raised were, can a system model simulate the stream flow? How does it compare to hydrological modeling? And will the downscaling GCM stream flow be something worthwhile? So those are something for thoughts. So more complicated is the ideology. So back to the swim flow data, there are other things about oh, sorry, I think I've talked about that. Sorry. So then the next thing we will talk about downscaling and bias correction in terms of the data set that are needed. So different people spoke about the data that are available in terms of their region, and at the same time, some are good over a particular region, some are not that good. So we mentioned that we talk about temperature. Era 5 was a common theme with virtually all the regions, but it has its own challenges as well. Some talk about chips that is good in North Africa, but for people in Asia, said it's not that good. So how do we go around? How do we address that if we want to do downscaling and bias correction? So those are the things that came up. The use of satellite products too came strongly, that can be useful. Your observations are not available, but what of the issue of the time, that sometimes satellite data takes about, sometimes about 4 days. So there are some things that might be missing, and I think Ben too speaks to that. And then the global data set that people can use as a proxy in terms of whatever they want to do for their downscaling method, and maybe whatever bias correction they want to use. Everybody knows Screw. Maybe it's easy to go to, but it's still a proxy. So what do we need to do? With some places are talking about in situ data that is needed for them, especially like those people doing, I think Franklin was talking about for their own region in East Africa, that some of these things are localized, that you may need some of these data set that are in situ to be able to do whatever correction that they might need. Then another thing is about, we talk about the large scale simulation that Ben was trying to address. That it's not just you focusing on the variables alone. What is, need to look at the things behind it. Those are things that we need to look at in terms of whatever downscaling we may want to use. And in area that mostly get extremes, we may not find that. Then talk about monsoon as well. If you care about it, what happens, you may need to downscale in some area. And then as regards bias correction, to be mentioned that is it possible for the modeling groups to help bias correct or downscale products? Though we know that was like $1 million question, because how far can you go? When we talk about, can we use the codex approach, but in terms of computational facilities and the cost, are we able to do that? So at the end of the day, so the proposal is for us to come together as a community. There's a proposal about writing a review paper on bias correction and the downscaling method that different people have used, so that for the community, then maybe some data set that works, we come with different impact groups, addresses it. This is the technique that they have to use it as data set that are available by different types of region, at least as a start point for impact modeling study and geoengineering. And then the proposal that we can detail which DCM outputs are suitable for different types of impact studies at regional level, and then maybe some variables that can be useful. Thank you. Maybe people from the group, if anybody wants to say anything at that time, I've missed out.
Thank you, Tammy. Thank you. Okay. Any comments and feedbacks from the room? So this is okay. So this is more, Tammy, the suggestion of review paper is to sort of compile things that people are already doing, right? But what is lacking now, and sort of the same thing that I said day one, is sort of a global downscaled product that can sort of also, it doesn't mean that it's going to be perfect, but it means that it's going to be something we can all benchmark against, right? So now you said ERA 5 has this 1/4 degree resolution new data set that could be a good place for it to start, but that's clearly something that's going to require a lot of manpower and funding. Like that's a scientific endeavor, so probably something that the review paper can suggest to have these downscaled data set. Doug?
So this is just a question of my ignorance in part, but to what extent is the bias correction and downscaling different for SRM studies than for climate change in general? And is there existing, so here's the workflow that helps speed up impact analysis for climate change in general that can simply be duplicated for SRM studies?
answer that. So there's a group called EasyMIP, ISI, which has a downscaling and bias correction protocol, which is already in use for agricultural models. ISI is intersectoral impacts, and so it can be used for other things too. And they typically run at 1/2 degree resolution. So there are biodiversity data sets, and they've used it to analyze impacts on agriculture for the next 100 years from the 2 to 6 models. There are papers on that. So we could use the same technology if we're looking for agricultural models, but for other models, they might need other variables at different resolutions. So I don't know about them. It might be hard to have a general downscaled data set that works for all impacts.
We use the same data set for the fish too.
The EasyMIP, yeah.
Bias corrected the downscaling.
And so also, if you're looking at local impacts, you're still going to want to look at local data. This is typically from reanalysis, but local data still might tell you that the bias correction isn't really perfect, and you might want to adapt it too for your local impacts.
While somebody moved the microphones, I'll just make this point. This is something I mentioned the first day, but so for GeoMIP 6, the amount of requested variable in general was 2,301. An average model submitted half of those, but if you pick the average of what 2 models had in common in terms of variables, it was half of that. And if you get to 20 models, they had in common only like 10 variables. So this is we're about to submit this one as part of the GeoMIP process. But yeah, just to make a point of if a model says, oh, we don't have this, or this we can have, and then everybody starts doing that, when you get to 6 models, the amount of variables is already pretty small. And so this is also another challenge through GeoMIP, right? And this is why it's going to be useful if we have a pretty comprehensive list of the variables that every modeling center should submit, and even if you want to do a data repository. So, Lily?
Yeah. I just want to add something after what Alan said about GeoMIP. So, excuse me. The downscaled product is not just for agricultural modeling, but like Kelsey said, it's also for fishery modeling groups, and it's also available for other impact models like hydrology and others. So I think we already have a workflow to take the like GeoMIP 6 model output and downscale those variables to 1/2 degree for impact models. And I think Cheryl, once I was involved in the email as well, right? We're trying to get in touch with GeoMIP and trying to put the geoengineering, any of the scenarios in their protocol and make it like a standardized way to produce the climate forcings for all the impact model. But I don't think it's really about like the labor, they have everything ready there, but they need someone to really work on this and create this data set and put it on. I think they use Globus to save the data and share the data. So everything is there. It's just a way probably needs funding and labor to really working on this. And another thing is they have a lot of discussion already to choose what kind of SSP they are using for analyzing their statistics impact studies. So it's a little bit different setup than what we are working on here as GeoMIP. They choose SSP1, they choose SSP5, but we are using SSP2 as the reference line. So when we are working with ACMEP, that's a problem. Most of the crop models, they did the reference case for those 2 already because that's their priority. So now when we are introduced any of the geoengineering scenario to them, then they add extra labor there. They need to run SSP2 4.5 as a reference case. So I just feel we need to really talk with them more, even at the beginning of the setup all the protocols and trying to make it easier for everyone.
Sorry, somebody's gonna have to, so Ben was first and then.
Yeah.
Cheryl, you have.
Oh, I can just add to that, so we're doing a fishman protocol. EasyMIP gave us space on the servers and we had to get all the files ready. So my programmer had to do all of the regrading and stuff. They're very supportive, but yeah, they don't have personnel time to dedicate to that, but they're very cooperative and they're like, yeah, you can do your own little protocol and we'll host it and stuff. Yeah.
Yeah, same for me. I basically needs to do the downscale,
Mm.
everything, prepare the data ready for agricultural modeling.
But it's something that if a proposal was written.
Yeah.
Then we could put money in.
Yeah.
Yeah.
So the review paper, sorry, Ben, the review paper should be explicit, and I'm trying to be more and more explicit about the fact that this just needs data people. And I know that Degrees has also put forward some proposals for that, but so.
Yeah, so I want to address Doug's question directly because we did talk about this in the group. And the short answer is we don't know. So the keywords here are validation and stationarity. So if you have a historical period, you can validate and bias correct your model. Under climate change scenarios, things generally scale with temperature, so you can sort of squint and use those same relationships from large scale to small scale extrapolated into the future. SRM breaks that. And so how bad is that? We don't know. It's probably okay if there's not too much geoengineering, but that's probably the best answer I can give.
So, Ben, I disagree on a little bit on that because, well, climate change also does break most of the relationships for observed one. And so it is probably impossible to demonstrate, but it's like, to me, it's likely that stabilizing the climate through SRM might give you, for some things, some better information than downscaling SSP 585, but it's kind of a thing that we will never be able to demonstrate because we only have one planet and we're only going to do one thing. But
Yeah, totally
Jim,
agree.
sorry, Al.
Exercise.
Not sweating. Yeah, I just thought one of the things that you've always got to bear in mind when you're doing these impact studies is that in areas of high orography, the global models can be really bad, no matter what. You know, if you don't have sufficient horizontal and vertical resolution, that's a big issue. So, you know, you maybe GCM for what we've got and what we're running for GeoMIP. I think at some stage we're going to have to consider, because there's a bit more resource coming into the areas, we're going to have to consider doing sort of high resolution. And I think that's something that we should really sort of consider maybe for the next, or a discussion on that maybe at the next year, because I think, you know, I've done some simulations where the change in precipitation in the future in the course models over Malaysia is north-south. As soon as you go to a higher resolution model, it's east-west. It's completely orthogonal. So those things need to be borne in mind. Okay.
I'll just add on that yes, that's a great point. CSM is like there's a lot of modeling centers that are developing these high res. I mean, Claudia just showed they're doing something right, but in terms of they're incredibly expensive and all of that. But for instance, a way to start, I already said it last year. If there's any grad student that wants kind of an interesting paper, MPI had two resolution for their model, a low one and a high one. The high one is the same one as CSM, but it would be, nobody has done yet a comparison of the low res to high res for the same model with the same thing that MPI provides. So if anybody wants to do that, let me know and we can coordinate on that.
You have to send me one.
So just to point out, it's the same for the ocean. The critical thing for biological resources is outgoing of nutrients, and that you need higher resolution in the coast. It's really hard to. We're trying to figure out how to do the biostructure down, but non-trivial.
Oh, my. The resolution?
Anything higher is better.
Yeah.
Usually we go to 10th degree, but still even that has biases, but it's better than 1 degree. Ideally, you have.
Okay, a couple more minutes on these. Anybody, Brian?
It's really just a note, there's at least 2 efforts going to compile different papers, just so you're aware, and if you have papers to contribute on it, from GeoMIP specifically in terms of downscaling impact studies, and Alex Wong is trying to create a database, and we could be able to pass that on. And then-
I have that
Oh, you
for
do?
the,
Okay,
for the
and
next
that's
part
the
of the, yeah.
Cool, and then I'm doing one as well, or coordinating one as well on impact studies with large for SRM, so if there are things, they're not just GeoMIP, that'd be nice.
Mhm.
You have that already, great.
I'll add something, yeah. Okay, anything else on these? Again, we'll bring these back after the coffee break when we sort of try to summarize everything for next steps. Okay, if not, Claudia, we can move on to the second one. That is the second breakout from yesterday with emulators. Want me to share?
Always so nice if someone else have the technical hassle. Right, so we had a breakout session on the potential use of emulators for SRM. So just for those who are not familiar, why on earth you want to do that? Well, I think the big problem with SRM research is there are just too many possible policy relevant or otherwise scenarios. So I've tried to give a rough illustration, but you see there are many branches that I didn't even continue. But if you imagine that your scenario is 5 degrees of freedom, let's say the background CO2 scenario, the SRM type you use, the injection location you use, the starting time, and the intensity, and each variable has 5 possible values, you end up with 3,125 scenarios. I mean, good luck doing this in Earth system model, especially at high resolution. So we thought whether emulators could be of help here, and an emulator we define for now as a piece of software that somehow imitates an Earth system model in that it produces the same or at least similar output, at least for a subset of the output you could be interested in, like for example, some variables. If you give it the same input, like a certain geoengineering scenario, for example, without running the model itself. And often emulators are more statistical tools than basically running physics themselves. And it could be many things they could be used for. So I mean, the one we had most in mind was generating scenarios or exploring which scenarios are interesting to run in a proper climate model. But you could also use, for example, partial emulators to emulate small scale processes in a big model, like for example, emulating LES simulations on plumes for aerosol spreads during SEI. Parameter tuning is also a possibility, and some that came up during the discussion. Inverse modeling and attribution, because for this you need to run a big ensemble of models basically. So if you could get that more cheaply than running the same ESM 100 times, that would also be a great use. There are different types of emulators, from very simple linear response models for just a handful of variables to big machine learning endeavors, either for climate responses or weather generators. Probably in practice, one could end up having a modular approach, like stacking something for global mean surface temperature, a pattern scaling approach for regional responses, and then a weather generator for variability, just for example. Also, we are currently working on a white paper. So if you are working on methods, send me an email and then we can include this. So there's some projects going on right now, but it's a bit scattered. So yeah, one of the questions we asked is, can we coordinate more? So basically we were discussing.
Somebody joins the waiting room.
Okay. So there were 3 things we wanted to discuss. We discussed more the first 2 of them. So first is model input. So if we would, in several groups, want to train emulators, what training data would we need and how could GeoMIP help to generate them? And the other point we discussed is coordination. So how could different groups who work on emulators coordinate more effectively? We did not really come to the third point, like who's the target audience and what do they need? But I think the impact breakout group may also, well, have at least produce some useful information of what should be included. So as regards the question of input data, after a bit of back and forth discussion, we think that for SAI scenarios, probably the most useful thing to have would be single latitude exercises, so that you could, in your emulator, work on how to combine the effect of different single latitude injections to generate the response that you would get if you combine them somehow. I mean, there's also already groups working on this, and potentially this would include both longer timescale simulations, but also an ensemble of pulse responses, so that you just run your forcing for a few years so that you could get the short-term response right. For marine cloud brightening, probably something around along the lines of Haruki's work would be the most useful starting point. And we also briefly discussed that maybe one should sort of separate the steps, how much to inject to generate how much forcing, and how will the climate respond to the forcing. So you could, of course, build an emulator that assumes a certain amount of forcing as given and computes the climate response. It is probably easier than the very uncertain part, how much injection rate to how much forcing. Then yet another approach that came up was using long pre-industrial runs for fluctuation dissipation-based approaches. But for all of these, the good news is that such simulations are not so exotic that they could not also be useful for other stuff. So even if you're not interested in building emulators, then for example, single latitude injection simulations could be useful for model comparison. And of course, long pre-industrial simulations are also produced routinely. Then another part of the discussion was about how to coordinate the work across different groups. And I think there are several points where collaboration or coordination could be helpful. So along the lines how the project would work, the first step is, can we share input data for training emulators? Of course, it would be great if there would be somehow a shared repository that's easy to use, where everybody could just get the input data to access, especially since, quote Daniele, ESGL. I thought I had to quote this because it makes me happy. Of course, this would require quite a lot of work and some funding for software people to get this done, as already we heard from the impact group as well. Then the next thing is, suppose I have made an emulator, so how can I share this with my fellow scientists, and vice versa, or can we update each other also about ongoing projects so that we have fruitful collaboration and prevent double work? That's probably easier because emulators are smaller than input data sets. We also discussed, without coming to a very sharp conclusion, about whether we should try to facilitate running such emulators on a cloud. And then the last thing is, should we make them, and how should we make them more accessible to a broader audience? I mean, not just scientists, but also maybe going all the way to building a web tool such that decision makers can play with such emulators and get a rough idea of what SRM could do or could not do. So we did not really find solutions for all of these, but as one first step, Daniele kindly agreed to make a partition on the GeoMIP GitHub website where we could share emulator code and maybe also have at least a list of input data, even if the input data would not be there itself. And Daniele and Doug also agreed to look through their own simulations that they have about what would be useful or potentially useful for such input data, and also put it on the GitHub repository. And I mean, shout out to all other modeling groups who have useful data. It would be great if you also could compile a list, like these simulations are there. Here's the contact person to ask for the data, and that could then also be collected here. So if you can't put everything in the repository, you could at least point to simulations at some centralized space. Something we did not discuss, but we should maybe at some stage discuss, is benchmarking. So how can we compare and emulators against each other and improve them? So as I said, we did not reach to that, but we did think we should organize a special emulator workshop next year. So we have not decided exactly how, but next year there's no GRC, so there could maybe be space for that. So hopefully people who are interested in that will join us there. Yeah, so much for our results and happy to open a discussion.
Thank you, Claudia.
I think this is great for science, but I think it's very dangerous to make things for policy or thinkers or for the public. Ben, I think, and Dan and I and some others, and Nina got a free lunch at the UC meeting by some AI people from Stanford who wanted to build an emulator for geoengineering. And they did, they made a website and you could choose how much CO2 is going in, you could choose how much aerosols are going in, and they fitted a curve and you could get the output of how the temperature would change. And they had some verbiage about how this is much cheaper than mitigation. I made sure they took that out, but they said, do you want to be credited in doing this? You gave us some advice. I said, absolutely not, because this is only temperature response. It doesn't have any of the potential negative impacts of SRM. And if you're just giving people that information without the whole picture of what SRM might do, it's really biases. And they said the solution, this proves that it works and we should do it. And they were surprised that we were gung-ho wanting to do it tomorrow. They were so naive about it. But I think people that look at websites that you make with this will be similarly naive. So it's really dangerous to do this without context.
If they are doing it anyway, then maybe the better response would be to make a proper one where they do show uncertainty and do show side effects, than leaving the field to these other people, right? I mean, you could also look at it from that way.
If you're sure to do that too.
But if you can't prevent others and you think they're going to do it, I mean, it's a very broad discussion, but then maybe better make a proper version than letting others do it.
Hassan, and then
So-
Cheryl, you have something to say? Yeah.
Actually, I think Claudia, you and I, we talked about this last night as well, and one potential solution that we kind of hit the nail on, granted it was like a couple of years in for me. Was that, you know, maybe a short course or something like that, that you can click through and understand some of these things at a very basic level before you have access to an emulator like that, would be one potential mechanism to try and get people to understand a little bit more about the uncertainties of that. But certainly, it should be a much more detailed version than this Stanford AI setup that you gave advice to.
Oh, I'm just a +1 for doing this for MCD. I've always thought like, it seems like a great function problem. Like, how does this work? And I think, what, I don't know who he is, it's a mostly linear, right? So it, you know, we have so much uncertainty about MCD right now, so, and where to do it. So I'm, yes, and there's some really good science questions we can do with this. I think that would be great.
Jared, there's Maureen and then Jim.
So I just wanted to point out another model error comparison project called ForceMIP. So Force Component Estimation Statistical Method Error Comparison Project. And I think they did maybe some of the benchmarking work or they're working on some of the benchmarking work. And they have a lot of the framework that might help design this. But basically, they have a suite of climate models that they're providing for people to train their statistical methods for estimating the climate response for a range of forcings I think they're working through making that all available. The last date for participation was March of this year, but I think you could provide a lot of the framework and maybe some of the benchmarking that you're talking about here.
Yeah, just regarding the MCV comments, just be very, very careful because, you know, things are not linear. Things depend very much. You know, this is particularly aimed at stuff. You'd be very, very careful of saying, okay, we can use it. Well, it's back up Alan's comments because there's just so many different modes of variability. You've basically got an infinite number of choices, an infinite number of responses. So please don't sort of think, oh yeah, we can do this because
Everything you for impact studies,
Yeah, but even for everything else, for sea level rise, for ENSO, we induced by non-judicious choice, we induced an anemia that was 8 times bigger than anything that's ever been seen before. Now, you can't do anything with that. You're just going to check, you're terraforming the planet if you do that to something that is less inhabitable. So, be very careful before we charge on with these things that we're making judicious choices. It's just.
I think it's a good idea to have simulation or maybe some or Southeast Asia or this like Bangladesh, we don't have very big resource to run and EPSM model. So it's give an idea about the region, but I think the uncertainty that I have seen for one small basin or Magna River basin with the ESM model, it's really huge with the means they really disagree among the model and the. But I don't know that how the precipitation is really how much affecting within the model. So ESM model. So it is maybe a little bit really dangerous to make it very kind of simple way to elaborate with the emulator, but still it can be helpful to give a kind of instrument to understand maybe small process or small region. That's I can.
I think that the idea of having emulators can be very useful, or usually it's useful, but that's essentially what I'm here for. So what we did with the super simple emulator of the single latitude injection points. And I think there is value because it allows your community essentially to reach out to other communities because it makes the output more accountable. And so I think there is a lot of value in that, and I think there is value in you being the one that produced the emulators, in the sense that because I'm working with them, I can have feedback on what the emulators can do or what cannot do. So like how to use it, how to misuse it. So in that sense, I agree with Claudia that was about like outreach, but like even within the scientific context, I think it's very important that you are on top of creating these tools and you kind of guide the way they are used. But if you do, I think it's super important. I think it's super valuable this stuff.
I'm just gonna try. I think this is a great discussion. Probably the first time that we are discussing this as a community in an open setting, so it's great. I want to channel a couple of different perspectives, not necessarily things I believe in, but I think it's fair to say. And one of them, because David said that today is not feeling well, but when we talk about, oh, this is dangerous, or we shouldn't, like essentially what Peter said, people will say, oh, that's essentially gatekeeping, right? This is saying we are the ones that understand this, you don't, so don't get involved. So finding a balance between, there are a lot of these tools for climate change right now. They're useful for communication. Probably once you dig into them, you'd realize that there are huge assumptions, but they're useful. En-ROADS was it's an emulator for climate change based on economic assumptions and blah, blah. It was very much incredibly used for the Paris Agreement, and some say that it was the reason why eventually many countries agreed to 1.5 is because people at En-ROADS show a few countries. John Kerry is super enthusiastic about En-ROADS and all that. So these tools can also be useful. On the other hand, true that, as to channel another perspective, which is sort of the Monica Morrison's perspective, which is, we need to do a much better job at communicating what are the limits, what are we building our models for, what are they fit for in terms of purpose, and there are different purposes. So it's a balance, and it's going to be a hard job, right? And not it's gonna take a lot, but I think this is the fact that we're having this discussion and maybe a workshop later is gonna help us work through a lot of these issues. And yeah, so those are the two unendorsed by me perspectives. Yeah.
So, I'm kind of wondering, you mentioned about the training data, so how good is it emulated based on how good is training data? The more the better, probably you get a more robust output. So, I do not have experience with this. Could you explain kind of briefly what kind of training data you need usually, and what's the effort? What kind of effort needed to prepare the data to share with others for those have experience with it? Yeah.
Well, I mean, let's suppose that your aim is to look at equilibrium response of SAI at certain latitude injection as just one example. And let's also say that you assume responses to be relatively linear, which is something that you would definitely need to test. In that case, you could look for certain injection latitudes. What is the response of the climate system for a normalized injection size at this latitude and that latitude? And you could then say, well, if I combine, let's say inject in 30 north and 30 south, you could just sort of add up these effects. I mean, this is a simple example, and whether such a simple approach works or not remains to be seen. I mean, maybe you would need some more machine learning based, for example, nonlinear interpolation tool or so. And then you would need more input data because you would, you can just say for each forcing type, I run one simulation to provide it, but you would probably end up doing some more complex sampling of the space for do that interpolation. So depending on how accurate you want it and how linearly the system behaves, you could get away with just having sort of one simulation per forcing type, or you would need to add more combinations to allow nonlinear interpolation.
So I was wondering about the input data, the data you use to train that. That's come from the
Climate model.
They come from the
Yes.
climate model. So basically you could also say your emulator won't be better than the climate model you trained on.
Yeah. Oh, sorry. Go, Lily. Yeah.
Yeah, just, I'm new to emulator as well, but I know there are a lot of uncertainty, but just to follow up with your comments, like it's probably a good way to communicate with other communities, like impact groups. So for me, I have been always very interested to like, if we can give a range of those changes to impact modeling groups, they can start right now instead of waiting for all those scenarios design and the our system model run. They can just use the range to test their impact model, temperature precipitation as the list they showed from the impact model groups discussion. So it will be really helpful for them to test their model and then to get a range of the impact changes.
I mean, one thing that you could do, I don't say it's the best one, but it's relatively easy. You could use the same emulator and train it on several ESMs. And then if an impact model says, I use that emulator to find the temperature in whatever your region, you could make the emulator display the results. Now the emulator emulates CSM, and now the emulator emulates UK ESM. So then you could relatively easily give the impact model a range, like the emulation of different climate models provides these and these results for that scenario. So that could be a way how to put uncertainty automatically sort of in your tool.
Yeah. To give another couple of examples, I actually think that there's so this is clearly one of the ways, right? You train, that's what FAIR also does, and then there might be fancier ways like Monte Carlo simulations to get better spreads of uncertainties. The other thing you can do, and that you can do very well with sort of the dynamical emulators, is that essentially you're forced to make assumptions about how things are behaving. And in those assumptions, you can propagate uncertainties by saying, you know, if from SO2 to AOD in CSM, we get 1 teragram to get 0.1 AOD, we can assume that maybe the process is not as efficient as CSM says, and so that these actually, there's a range, so you can sort of manually propagate uncertainties in a way that actually makes you think about each process. So I actually think it's very promising. And then there's a there's some interesting things with machine learning. For example, there's like 76 models that have run historical simulations, can you train on a subset of GeoMIP simulation and get the uncertainty from the broader CMIP6 ensemble, even if they haven't done GeoMIP simulations? We're testing out things. It's really at the beginning but I'm pretty confident this is going to be a very good way to. There's tons of different things, and the climate change community is sort of well ahead of us, and we have some different challenges. But yeah, it could be very good in the long run to keep putting some focus on this. Any other comments on this? No.
Thank you.
Okay, thank you, Claudia. Yeah,
Thank you for your
yeah,
input, everyone.
thank you. Jesse said that he was busy until 10. So if there's anybody else from the policy relevant.
Jesse's not here.
No, he said he had a call until 10 and we're a bit early. Yeah. Let's keep talking about it. Yeah.
I'm completely ignorant when it comes to emulators. So what value do emulators add to the ESM model? What's the value add of doing emulators?
I mean, the simplest value is, let's say for climate change. I mean, okay. So as JF pointed out yesterday, the IPCC actually now uses essentially mostly emulator to then do the things in working group 1, as in you train on SSP 585, 70, 45, and then you essentially linearly interpolate. Like the simplest emulator is just a linear interpolation across the 5 representative scenarios that you have, and then you can get things like impact per degree of warming, right? That's that's been emulators for a while, right? And then there are more complex one now for climate change, like Mesmer, that also gives you extremes. There's speeches that has been developed by PNNL, where you get essentially another way to get time series of scenarios you haven't simulated yet. What if you have SSP 370, but with aerosol emissions from 245, right? So essentially, it's like a mix and match of that. You can do it even sort of from more basic simulations, which is actually a better approach, in my opinion, as in you do 4 times CO2, 1% CO2, and then you have regional aerosol forcings singly, and then you can combine all of them. The question is, how good are these emulators then doing out of the box? As in, if you're doing something that is more than SSP 585, it's probably not going to be good. And so there's a lot of interplay there. For SAI, this is the same, right? The one that Jared has developed, essentially, once you start having the combination between single injection latitudes, you can start asking, okay, there's probably a million ways in which you could do SAI non-cooperatively. How do you combine all of them? You can do simpler games. There's tons of stuff in there as well. Maybe eventually for MCB as well. That's sort of essentially it's interpolation. And also giving you a quicker response, as in you have a website, there's one from the Washington Post about how our extreme temperature is going to change in the future, right? And then you can say, okay, let's start by keeping humidity fixed and radiation fixed and just change temperature. And that tells you, okay, your heat wave is going to be 3 degrees warmer. Then you say, oh, but what if humidity changes as well? And then say, well, the perceived you can build on top, and that's a tool to communicate to laymen what could happen. So that's another way you can use emulator. You can run it on a web page, and it gives you some information. And as long as you're careful about giving all of the context, it's something useful for people. If maybe there's other ways that I've forgotten, but I'll give the microphone to Andrew.
I'm interested to understand whether there is value in doing some kind of MIP equivalent for emulators, so that we understand better how they pair with each individual Earth system model that they're trained on, and whether the individual emulators are useful for certain characteristics of the climate system. So some might be better at downscaling, some might be better at managing stratospheric aerosol layer, those kind of things. So I don't know enough about the subject to be able to intelligently comment on it, but I've never done that topic before, and I'll recognize fill in the gaps.
Oh, yeah. Essentially that's the benchmarking topic, right? How do you benchmark things that are about future projections and, Duncan Watson Paris is one of the probably foremost experts working with him a little bit on this. How to figure that out. It's pretty tough.
Dan, you just stole my point.
Oh, sorry.
I say exactly that, but I think there's questions of sort of how we think about these emulators as modules and design modular infrastructure so that you can stack different potential emulators with different potential impact analyses and have ways to do benchmarking across all of it. So thinking of it like a software suite and trying to be really clear about them being modular infrastructure.
Like, maybe in 3-4 years, we can have a GE, which is the E is for emulators. Or GeoMIP or GeoE. No.
I was
GeoE.
figuring out exactly that name.
A
and thought it was
GeoE.
right here.
GeoE. Okay. Jesse, you're up. You're not. How did you send them to me? I am not gonna share my WhatsApp in a public screen ever. So no. No, you don't. You absolutely do not.
I mean, it's just a single slide. I don't know.
Then, okay, you can just
It's
probably.
just
take it
like
out.
the headline messages. If there's an easy plug-in here.
No, yeah.
To my computer, then we can do it that way or not.
No, I can. Yeah, I'll do this. I'll do this. I'll airdrop the link.
Airdrop.
Yeah, I don't know.
Wow.
Sounds cool.
Sounds very.
It's the dumbest thing, but
Very
no.
Macintosh.
Yeah.
All right. You'll get the slide ready. Why don't I go ahead and start talking?
Yeah.
Because the slide doesn't come until the middle part of my summary. Okay, get my notes here. All right, shall I take the mic?
Yeah.
Okay. Thanks to Daniele for volunteering me to unexpectedly moderate and report back on the only breakout session, which didn't have an assigned moderator. The topic was called policy relevant or plausible scenarios. And that's all we had to go on. So the conversation began by sort of diving into the two halves of that phrase. So first to reflect on what we talked about, plausibility, is that the term and its similar word feasibility. Those terms are often used, but rarely defined. They have aspects of, you can talk about physical plausibility, economic, technological, social or political. But does this matter? Because as it was brought up under the term model kicking, climate modelers regularly use implausible scenarios that are useful, right? I mean, what RCP 8.5 or RCP arguably 1.9, don't mean to get too political here, but those might not be plausible, but they're useful and they're informative. Likewise, some of the early GeoMIP experiments like G1 is conducted under a quadrupling of atmospheric CO2, if my memory is right. Not plausible, but useful. So at the end of the day, we abandoned this as a concept, and we really focused in the conversation on policy relevance. What could GeoMIP do in its next generation of policies to be policy relevant? We didn't spend too much time talking about what policy relevance is. We did have one comment that said having a potential benefit or risk for the constituents of a policymaker, the voters, the citizens, or what have you. But the heart of our conversation was exploring specific things that GeoMIP could do to increase scenarios' policy relevance. And having reflected on the conversation a bit, I put these into 4 buckets. The first and most salient, if you will, of what we discussed about was the choice of metric. So most, if not all, GeoMIP scenarios, as far as I know, have focused on radiative forcing or temperature, keeping that within some bounds or returning it to the pre-industrial level or whatnot. But would it be more policy relevant, at least in some contexts, to focus on something like soil moisture or precipitation. Soil moisture typically being precipitation minus evapotranspiration. And the inspiration from that was the observation that in some relatively dry, especially low latitude areas, that changes in precipitation might be more relevant, for example, for agriculture than changes in temperature. So this might be one way to be more policy relevant. Or look directly at impacts that perhaps a future generation of GeoMIP models could minimize impacts on agriculture and biodiversity, or what have you. But before I go on to way number 3, we had perhaps our most substantial conversation was between B and C of what's on the screen here. That would it be feasible or desirable to move directly to C, move directly to talking about impacts? Would that be too big of a step? Would that be too complex from a modeling perspective? I don't know. There were cases made on both sides there. Second category of ways to increase policy relevance of scenarios is what to do with the metric. In other words, what statistic to use to optimize. Now, of course, typically we talk about the average, typically the global average. Can we return global average temperature to pre-industrial or keep it at 1.5 or whatnot? But we're also interested in the variance of whatever the metric may be across the globe. So there could be an objective to narrow that variance, to avoid extreme heat or extreme drought or extreme precipitation events, right? So this is something of more of a mini-max strategy where your objective is to minimize the occurrence of extremes. Or that perhaps there could be a way there to use a formula or an algorithm. Apparently there's some that are used to some degree that take into account both mean and variance of the metric. Third aspect of scenarios to examine is what's the reference RCP? What's the reference scenario? And there was the argument made that the lower RCPs have more, arguably have more policy relevance. And in that sense, the G6 1.5K was a big step in the right direction, because its baseline is RCP 4.5, which is arguably sort of what we're on track to do right now with a little bit of optimism around policy and what can be done with SRM to limit warming to 1.5. So perhaps the next scenario could say, well, how might geoengineering be used to take 2.6 and cool down to 1 degree warming or even half a degree warming? And then the final way is sort of a grab bag of other options. There were discussions of peak shaving, as well as the possibility of having standardized scenarios that would propose to optimize the climate in one particular region and then examine impacts across the globe. And then finally, to wrap up my summary of the discussion, are 3 sort of miscellaneous observations that didn't really fit into the previous points. Number 1 is the importance of linking GeoMIP activities and planning into policy relevance. Now, of course, to some degree, this is already done via CMIP. GeoMIP feeds into CMIP, which feeds into the IPCC. But we also talked a bit about the importance of actually speaking with policymakers. What do they want to know? Second point, are we getting a little bit ahead of ourselves here? Are we optimizing too much? Are we making scenarios that are too complex when we're at a stage where policymakers are just now learning about SRM and it's just on their agenda? So the idea of optimizing 2.6 to 1 degree warming or optimizing soil moisture might be unnecessarily complex. And then the third miscellaneous final observation is that scenarios of success and failure are asymmetrical. There are always more ways to fail than to succeed. Now, of course, both are important, but if you give equal weight to every scenario, then you'll spend the vast majority of your attention on failure modes, because there's an almost limitless number of ways to fail. That it's important to keep the arguably disproportionate attention on the ways of success, while also bearing in mind the opportunity or the ways in which the scenarios can fail. And that was our discussion yesterday. Thank you.
Thank you, Jeff. That was I knew I always know who to nominate to get the best job done.
Thank you very much. That means a lot.
Okay, this was great. Good way to conclude. Any thoughts? Yes.
Okay, so I'm just gonna reiterate what I said in the breakout today. So as a person who's trained in engaging in policy development science from being a grad student, there's a whole body of literature on this and a whole community of practice. And so, you know, and climate modelers aren't trained in that. Like, you know, nobody ever taught you how to do it. It's not part of your training. And so if we really want to do that, we need to engage with the people who are experts in this. And a lot of it involves co-design, but there's people who can help us with that. So we can invite the policy people, and there's a lot of policy people working within the geoengineering space that don't come to this meeting. So if we really wanted to do that as a community, we can really invite them to have a special session, you know, and really ask for that help.
Yeah, this is great. I will say also, Jessica said she had to leave this morning, but she's gonna make the slides available with a lot more comment references. And she's also available for a longer webinar if you're interested to talk more about these calories here. So we're working on that.
Great.
When I see that first category, my sense is that that's getting way ahead of things in the, you know, things like precipitation and soil moisture are not as well captured. They're much more spatially variable. And so they're not straightforward to target. And where we are in terms of the research is much more, hey, if you cool this much, let's understand what would happen to everything else. With the recognition that almost everything, not everything, but most things kind of scale with how much cooling you're doing. So that, you know, just picking the 1.5 degree number from the Paris Agreement gives you a point. But it may be worth discussing, and it's a trade-off of modeling effort to explicitly have tier 1 multiple amounts of cooling. That's sort of what we did in our simulations a couple of years ago, primarily to not because it necessarily changes the answers that much, but because it changes the mindset of making people recognize that there's different ways of doing this. And I guess one specific question there as well would be, you know, if one wants to look at different scenarios, we had the discussion yesterday about the polar one. And I don't think that's going to be an immediate thing for GeoMIP, but that also again sort of forces the discussion saying, look, it's not one thing, it's not one choice.
And the emulator, right?
And then the emulator basically can fill all the rest of it.
So we have Shingo, Jim, Peter, and Brian. I'm keeping track.
I pointed it already.
Okay,
I pointed out by that, so.
that was easy. So Jim, then Peter, and Brian, then Oliver.
Okay, I'll jump back.
Oh.
Thank you. I just think, as a community, sometimes we also lose track of what the policy relevant scenarios are and what they're intended to represent. So I've heard a lot of criticism about the SSP 585. But I would really encourage people just to go back and find out what the SSP 5 scenarios are supposed to be doing and representing. There's a paper by Riahi, which has been cited 4,567 times, that sort of lays out what the SSPs are supposed to represent. Now, we've all taken our sort of like, I'm going to quote a little bit from it, but we all take, oh, SSP 585. Oh, that's not realistic. But just listen to this bit at the end of it. Local environmental problems like air pollution are successfully managed. There is faith in the ability to effectively manage social and ecological systems, including by geoengineering if necessary. Now, in this case, it really is talking about SRM. So, you know, this is very important because what they do with their SSP is they include all of the CO2 concentrations at high levels. But if there's faith in SRM, you would be offsetting some of that high radiative forcing by SRM. So the temperature, so it's basically exactly what we've done in our GeoMIP G6 kind of scenarios. So please, you know, I think there's these misconceptions that people go, oh, SSP 585, that's not realistic. It was always supposed to be used with SRM. Go and have a look at the paper if you don't believe me.
But that gives people permission to continue to dump CO2 in the atmosphere.
Of course,
all its other impacts.
But I'm just saying that is what it was. That is what the SSP 5 scenarios were always intended. They were not intended to be, oh, you know, we're just motor on and regardless of temperature change. There's confidence in SRM, which will bring the temperature down.
But temperature is not the only thing that the CO2 does. So
no, of course it isn't.
Confidence that we can continue to
acidify
the oceans.
But I do think that it's an important point. You know, people say, "Oh, SSP 585 is not or is not relevant," but it was always supposed to be used with SRM.
I will also briefly add that while it's true that emissions are tracking SSP 245, top of atmosphere radiative imbalance is tracking 5, it's tracking 70. So it could be that emissions are low, but we're sort of out of we're sort of not in the right direction in terms of forcing it because the sensitivities are higher than we imagined. So there's still a lot of use for that.
Well, briefly on SSP 5, it does have a sex coupling for per capita coal consumption by the end of the century, which seems a little bit of a stretch. I think just sort of building off of what Doug was saying, I think temperature will be the obvious thing to go for. And I wonder if the policy relevant challenge is doing a comprehensive evaluation of all the things that matter, not so much as exploring the scenario space, but you know, what does this do to fisheries, what does this do to fire risk, et cetera, et cetera, et cetera. And then I think one of the biggest challenges, or one of the things perhaps this community or the wider community will need to help policymakers with is how should we choose among these issues? We've never had to trade off ozone loss against temperature. You know, this region getting drier against it being cooler. I think that evaluative question is going to be one of those crucial things, because I think optimization, we don't know what to optimize. And so we pick one thing, and then obviously in the real world, therefore we'll be considering all of the things. And so how do we weigh those against one another? I think is something we haven't had to do for climate change, but I think it comes much more to the fore here. And my sense is we'll go for something simpler and obvious, like keeping temperature constant, for want of a better idea, and for it being so complicated. So I think optimizations really, we're too early, we don't know how, so.
Brian, then Pietro, then, Brian, then Oliver, then Pietro, then Tyler.
Yeah, I just wanted to connect this briefly. It's connecting in my mind that the choice of metrics and things can connect to that emulator discussion we talked about with other people. In that the emulator is useful for research and it can be misused for the promotion of things, as Alan was saying. But if there's not a direction to it in terms of your goal, it's simply, hey, you're a policymaker, explore this space and new questions may arise. It can help guide those sorts of metrics. Like I'm thinking people here, generally speaking, are not the people who best choose metrics for policymakers. It's policy relevant people who are asking for policy relevant questions. If the goal is to inform policy, if it's what we think should be informed policy, that's very different than, or potentially different than what other people say. And the other thing is the models, using an emulator to get at policy relevant questions, or using tools like that to get at policy relevant questions, may also expose the best way to actually affect policy change, which may not be through a model. It may be, hey, this is how close the models are tending to get. Maybe there's other people you'd like to talk to, or other sources of information to augment these model outputs.
Thank you.
Oliver?
It's almost same as Brian's, which is that I think this came up in the discussion. If you want to give policy relevant advice,
find policymakers and ask them what they want. And if your answer is, well, we don't know any policymakers, that's the issue that needs to be addressed first. We need to find people who can be talked to by this community. I think that actually, I think given that GeoMIP is about modeling into comparison, I slightly worry that at the beginning, the policymakers are going to say, well, I'm not interested in model into comparison. I'm interested in what's going to happen. And you have to have an answer for that. But find some policymakers, and if there aren't any, and if there aren't, then some people in this community should be going and finding policymakers who aren't interested in soil geoengineering and asking them so to be. Because I thought it was a fascinating discussion yesterday, but it did come away from it slightly thinking we don't really know what policymakers might want from this particular group.
Yeah, that's a very good point, Oliver. I will say that policymakers are actually interested in a lot of, some of us here in the room do get asked to talk to them. Now, especially the WCRP has been a great opportunity. There's a lot of governments that are really emailed the WCRP, be like, hey, can we get in contact with the co-chairs because we have questions? And the questions are not dumb, which was a bit surprising, but but no, it means that they're paying attention, and so we're starting to understand what it is that they want to be better.
Yeah, no, I just wanted to agree on the later point, I think. Well, Pete was saying, I think there are space to use emulators in terms of like simple, semi-conceptual, multi-objective optimization to explore where are the big trade-offs, if there are big trade-offs. So I think that's a promising lane. And also on the scenarios, I agree on the fact that going up, especially, I mean, maybe 8.5 might be excessive, but there's sensitivity 7.0, which is also interesting from a narrative perspective because you have the non-cooperation dimension. And instead of going down, I think that there is value in being a little bit imaginative of what can happen on the mitigation side, meaning that yes, we are currently on track for 4.5 or so some literature says, but things are good. So there are a lot of net zero commitments, which for now they are just commitments, so you can just increase them. But 20 years ago, the NDCs were not there. So I feel like exploring the space in between 4.5 and 2.6 has some degree of value because it answers the question: does geoengineering help as a role, even in a world of acceptable mitigation levels or not? Or is it just a thing that you need if you go again 8.5, 4.5? Right? To me, that would be an interesting question to be answered at the physical level by this week.
Yeah, and thanks, Jesse, for your summary. One of the themes that came out from yesterday was this fact that Oliver just mentioned also that this policy maker is likely hypothetical or ephemeral or rare. But in the meantime, as Oliver said, we can talk to the policy, either the policy talkers, the people who are thinking about the policy who will help influence it, or as Cheryl mentioned yesterday and today, the stakeholder relevant policy thinkers, where we can influence the policy that way. I would encourage everybody in the room, if your paper is policy relevant in some way, to state that in the paper and explain why. And the key reason why is it presents a choice that you think the future policy maker might face between situation A or situation B, or this is important in this way. Just a suggestion.
I just want to comment on one feature of SRM that's very different from climate change scenarios, and I think it's what people tend to anchor on, right? Is when we make policy decisions for climate change, there's a lag between that and infrastructure, and a lag to emissions, and a lag to CO2. And so, there's really only so much space in the future for different possibilities. With SRM, if you were doing half the cooling and you decided you wanted to completely change your strategy or turn it off or do something totally different, that happens much faster. And I just wanna, get that in people's heads of not reifying the scenarios too much. Right, I think people in climate change, when you're looking at climate change policy, it's like, oh, we're gonna go follow this scenario, we need to push it down and follow that scenario. But we're not gonna follow any of these scenarios, and it's not even close.
And Jessica had a good point. She left, but in her email, she said, the CDR community, in a way, the IPCC and the CDR community made a big mistake in the scenarios for GeoMIP 6, where they had completely unfeasible and unrealistic CDR scale up, and that has led to some actual factual misunderstanding in policy and around net zero policy. And so going back to the discussion with Wake about what's feasible, there are some lessons about scenarios that are so unfeasible, but they change policy in a way that we would not want to. So.
Just a brief note. I mean, I think, well, while I was saying, I think the trade-offs between the things we might care about are complicated, like for this friendly, regional rainfall change will be different, but temperature will be so and so. I think what matters is not mysterious. We're not coming out of nowhere in completely naive into the world. There is however many decades of climate work that said, here are the things that matter and we care about. And so I think we don't necessarily need to ask individual policymakers what they're particularly interested in. I think reporting on the things that we already care about for climate change and telling them what, here are the things that IPCC thought were important and here's how this affects them. We don't need to completely reinvent the wheel here. There are some new things, but it's well trodden ground.
I'll keep it forward. We don't say you're naive anymore. We say you didn't fall out of a coconut tree. That's the.
Is that what they say?
Yeah, it's because that's what the Democratic candidate.
I think that's, there's obviously a truth there, but I think what I was going at was more, as I meant, actually find a particular policy person that you think your paper is relevant to. It's not just because you can write things that are relevant to things that the IPCC has said are relevant, but it's not, we had a bit of discussion, I said, it's not commutative. It's not like relevance just continues unabashed down a chain. So you have to find someone who thinks this address is relevant to that thing which the IPCC is relevant. If you just keep on producing things that are conceptually relevant, given the conceptual ideas of relevance that the IPCC is provided, I don't think that's as effective as actually finding people who want to know answers.
Yeah.
Yeah. Okay, on these notes, it's probably time. Okay, we have, well, actually, there's somebody who hasn't spoken yet and want to do something else. Otherwise, we can break for coffee and reconvene at 11. I'll give an overview of the things for this week, and we'll have some time for final decisions and all. But you deserve your coffee. Thank you all for the discussion.
What about?
Okay, if anyone else would.
Yeah, I think actually, and maybe that's, but yeah, you can just answer and
He knows we're totally tied up.
yeah, no, he knows that. Yeah, just maybe This evening.
I've actually lost track of whether we were on this supposed to be responding to something.
No, I think people, unless you're people, the engineering.
Well, I don't know if they.
No.
Yeah.
Okay. Okay, okay. Ooh. Okay. Here we are, so I think when I mentioned it to a few people, like maybe we should end up before lunch and everybody was like, oh, yes, so feedback received. So we can wrap up. Essentially, what is this session about? Every remaining discussion, anything else that people want to talk about, and sort of a task list of things from the GeoMIP end, which means from everybody's end. But you know, if anything, feel free to raise your hand, say anything at any point. I just have put together a few bullets this morning, but if you think there's anything I missed or anything you want to volunteer for, nobody ever does that, but I always say it. So the first point that I want to make is that your feedback for these meetings is always very important. And a lot of the things that I think we did this year that everybody appreciated were actually things that came out of the feedback session last year in Exeter on Friday from the early career scientists. They had a lot of amazing feedback that tried to implement longer meeting, breakout rooms, a prep document with some background information. I think those are all things that people appreciated. So even for this meeting, either now, after in private, send us an email. Your feedback is what makes these meetings successful. So, so the sort of next steps, again, for GeoMIP, as every year, we'll have a report. Last year, we made it available for comments for sort of a month. Nobody gave any comments, but okay. But you know, we'll do the same this year, and so and please read it and make sure that you feel like it's been reflected. We normally publish it on BAMS. Then all of the previous reports are on the GeoMIP website. And then, of course, there will be eventually, we'll talk about that later, there will be a GMD paper for CMIP 7 eventually coming. So operationally, the other thing is that, right, we've decided degrees had asked to make the decision before this meeting. So we asked the GeoMIP steering committee, who's always a great support, to help us decide. And we agreed to have the meeting, the GeoMIP meeting, the 15th one, together with the Degrees Global Forum. So we'll be in touch with steps for organization. And the thing is that there is funding, both, I don't know if Alan, you still have some NSF funding.
No, I'm waiting to hear my proposal,
Okay.
so if I do, okay.
But I have QCF funding that is explicitly for next year travel. So if you want to join, please get in touch. Well, again, when you have, and if you are in doubt, ask, as in don't assume like, oh, I didn't ask because we thought the funding was for somebody else. Like just ask, and then we'll try to do the best we can in terms of fairness. The other idea that was floated around 2025 or maybe 2026 at this point. So first of all, the last year we had this early career sort of school that everybody found useful. I don't think there's going to be time in 2025 for sure, but maybe then we can start thinking about 2026. With Ben, we floated maybe some vague ideas about sort of a hackathon to start developing code for reproducibility and all of that. Again, we can think about that. For all these things, whenever you have whenever you have ideas, send us an email, write on the GeoMIP mailing list if you just want volunteers. So this is sort of the high level thing. I guess we have to start thinking about 2026. So if somebody wants to start thinking about volunteering to host the 2026 one, I mean, you have the whole year, but then by next year, by South Africa, we need to sort of have some volunteers. So think about that as well.
And based on your experience, would you recommend
No.
hosting it?
Yes, no, it's a fantastic. It's the most relaxing thing. I feel 10 years younger. I would absolutely recommend. It's like For skincare, for skincare. We have had it, I think the Zurich one was in May, April.
Which,
The Zurich GeoMIP meeting was in April.
yeah, so is the one in Paris.
So it's,
But I was gonna say, Louisiana, you wouldn't wanna go there in the summer.
yeah, no,
Yeah.
for sure.
Sauna all day.
No,
You know,
These must be nuts.
the problem is
Yeah.
visas, everybody can't get a
Yeah.
visa to come here.
yeah, I would strongly recommend not having it in the US any longer for this specific reason, because this was a mess, and it just signing, like just helping everybody with the visa was, but also then a lot of people couldn't make it at the last time. Europe is a bit better, but not so much. Degrees now is thinking about this a lot in terms of equity.
Yes, Latin America.
Right, we could, yeah, oh, I mean, Mexico was lovely. We had a degrees meeting in Mexico and it was just so lovely. Yeah, we need to think about it. Latin America seems good. We'll see how South Africa goes. Degrees has had a lot of luck with Turkey, because it's a place where everybody can reach easily, but we don't have any local hosts in Turkey yet, I guess. So, you know, we can think about it. We have the whole year, but definitely not the US, and definitely not next year, in the next few years. So maybe we can think about something better. We'll see.
We alternated between Europe and the US,
Mhm.
but then a lot of people from out, who should be here, a lot of people who should be here started coming, and, that made visas, more problematic. There
Yeah.
were people that couldn't get to Exeter either.
Yeah. And I think there's a lot of merit in finding new places, because then the local community can join. We've had a few Cornell people in Exeter. There were a lot of the Exeter professors. Maybe there's a option for Asia. Again, where's Shingo? Shingo is pretending he's looking at his phone, but you know, we'll see. Andrew, sorry. Is it brief?
Yeah, I was just gonna say, I think it's really important that we try and make an effort to go to climate vulnerable states and ones that are not part of international discussions, because I think that people's personal experience of visiting and meeting people from those states is really important.
Yeah, that's true. So again, the thing is that the way we run GeoMIP is that somebody has to volunteer, and there has to be a local host, because we don't have the capacity to sort of just go somewhere. Again, we'll talk more closely to Degrees, which is they're one of our fundamental partners, and see. But yeah, that's right. In Mexico, we've had incredible discussions about heat waves and how that motivated Mexican researchers to apply for Degrees grants and to look at what would happen to heat waves in the future. I think that's very important. So we'll see how South Africa goes. It's going to be our first attempt. Here.
Question sort of looking ahead. I mean, if this field grows as rapidly as it might do, should GeoMIP still play the role of having a very, very broad umbrella? Or should it split and there be sort of a evaluate the consequences MIP, whatever project, and how precisely are we doing the modeling GeoMIP kind of thing? Because I wonder, you could quite easily see this grow to twice the size, 3 times the size in the next 5 years. And would that still be an effective way of organizing and running this stuff? I love everyone being here. I'm just kind of wondering, thinking whether it makes sense to keep doing it under one umbrella.
That's an excellent question. One of the things we pointed out already last year was that the lack of something like CEC and the sort of the high step of sort of the Gordon Conference made these a place that it made sense to have a broader umbrella. But we'll see with the global forum is essentially that becomes the venue, and we can sort of go back to just again, also like we're going to be talking about new simulations, the initial results next year. So it's going to be sort of tied to the rest, so we don't have to do everything at the same time. Yeah, Claudia, and then Alan.
I think we should also, on the other hand, beware in splitting into too many small meetings, because even if you just look at the carbon budget of getting everyone together, it's such a global field. I mean, having a 2-day workshop here and then a 2-day workshop there is also messy. So maybe what we could, if we want to, well, split things or have different sub-meetings, and maybe it would still be an idea to like have things in a row or something, so that we don't have all this visa and airplane hassle several times a year.
And I wanted to point out, for two of the Gordon conferences, we had GeoMIP meetings, as a side meeting one afternoon, and that just wasn't enough time to talk together and to discuss things, and that's why this year, for the Gordon conference, we didn't have a GeoMIP meeting, we decided to have a separate one. They gave us time to do all the things we did here, and I think that's important, and I think it's also, I agree, we shouldn't have too many meetings to go to, so. This is working, this one worked fine, and I think we have to carve out, be sure we carve out enough time for us in Cape Town. We have to work with them to organize at least a couple of days where we can be separate from them, or they can listen to us, but, or maybe we could be the main item on the agenda, so not just an afternoon pushed to the side.
Yeah, no, absolutely, absolutely. Cheryl, and then.
Can I just ask one other thing? Are we going to make any recommendations at this meeting for new experiments?
That's in the next slides.
Okay.
This is just the first item on the, yeah. So Cheryl?
So we had this exact issue in FishMIP over the last 6 years. It got really big. And what Julie Blanchard did, which I think has been extremely effective, is we divided into working groups. Like Kelsey's in the biodiversity working group, and those meet online. And we have the added issue of multiple time zones, and then we have like big things where we all get together, and the working groups have these little, they're working on projects, and then we all come together, and that's really effective, and that could work well, given what I'm seeing, how things are kind of spreading out into different interests, within GeoMIP, that can be very effective.
I kind of had something exactly like this proposing yeah, that's great. Thank you, Cheryl. Yeah. I think there was Doug, Ben, and then Oliver. No, okay. Yield the floor. Go.
Thanks. So, I think it might be worth us stepping back and taking a more holistic look at what we want the community to look like instead of trying to shoehorn into a framework. So, GeoMIP was part of CMIP, which was part of WCRP, because that's what there was. That was the framework that existed. We were, I think, the first satellite MIP, which is now sort of their standard practice. Now WCRP has a whole activity on geoengineering. So GeoMIP is still really useful, but it's now one important piece alongside a lot of other important pieces. And it's a different world, maybe requires new thoughts.
Oliver, sorry.
Yeah, I wanted to say as the chair of the Degrees Initiative, that we're incredibly excited about doing this with GeoMIP next year. And if I can following the grand tradition, volunteer Daniela for some more work. When you provide feedback on this meeting, please also provide any aspirations you might have for what you would hope for next year. I really hear Alan, we want to do this so that you get a really good GeoMIP meeting and everything else is good about the global forum. We don't want, and to the extent that there might be trade-offs, we want to be absolutely informed on what you want as a community out of those days, because they could be great days, there could be fun days, and we need to make sure that we know what you want from them. So,
you've been here, so you sort of know what we do.
I know what you do, but that doesn't necessarily mean I know everything you want. I have not looked.
Don't worry, we'll
deep
talk.
into all of yourself.
Well,
We'll
says
tell
that they
you.
want as much as you want.
What?
No, not everybody's as vocal as you about what they want. They're quieter.
John?
So, I kind of building on this point that Ben and Oliver have made, it might be something to consider to try to get some good publicity, PR work out of this kind of a meeting, to show people that, I don't know exactly how, we either have some people filming, to show how responsible we are to consider things that are outside of just purely the engineering or the computing science aspects of it. Like, I think Degrees did something like that at the Gordon Conference, interviewing particular people. But I think some of the to and froing here could be very beneficial for our standing in the general world, where everybody pretty much hates the kind of thing that we're doing. And we have to somehow neutralize some of that feeling to show that we are more like real people trying to do the best job we can from it.
Good of you.
So like inviting the press or?
Well, there are companies that would love to film, for example, our deliberations here, the non-use agreement deliberations, and make that kind of a contrast and see, you know, how it looks to the public. Obviously, that depends on the quality of the editing that goes into something like that, and we have to be very comfortable that it doesn't stop us from saying the kind of open discussions that we want to have.
That's okay. That's an interesting discussion worth having. For instance, I mean, okay, this is not good editing, but I have recorded all the plenary sessions. The other time that I did it, it was only for the participants, and then maybe we can have a discussion or whether it makes sense to just have that public. But that does hinder a bit the way in which people feel free to say things, so it's something we need to balance. Degrees people?
Yes, degrees people here. I have not seen or heard the dates of the Degrees Global Forum, which will be held currently with GeoMIP 15, and that is May 12th through May 16th next year at the Century City Conference Center in Cape Town, South Africa. My colleague Nick has one more thing.
I announced that at the welcome of.
Oh, sorry, that was my travel delay, so I was absent. So a reminder.
Yeah, sorry, mine was just to John's point, which is, yeah, like Danielle said, it depends on sort of how we run the exactly, which doesn't understand yet. But it's definitely on our radar, that type of thing is sort of opening up somewhat that discussion, that scientific debate that's happening here, and the concerns that's obvious in the community around, you know, this technology and how it works. So yeah, I think it's definitely on the radar.
Anyone else?
Yeah.
Yep, please.
I just have a small contribution to the discussion about the prospects of opening up the videos and whatnot. John, I'm with you in spirit on that. I think I've been doing a little bit of work with some recorded calls with scientists that generally have been taking an hour and a half to get them expressing themselves in their own words without charts, graphs, jargon, kind of as if they're speaking to non-scientists and just giving them an update on their take on climate solutions. And generally from there, we edit it down to 5 minutes after an hour of playing with different wording and whatnot. And I would encourage the process closer to that so that the scientist gets a chance to kind of think about how it's coming out and make sure they like how they sound.
Okay, anyone else on this point? Otherwise we can start, okay. Good, so I feel like we have things a bit settled and we'll continue discussions here. Okay. So right on to the main point, which is, okay, we need to start really making some recommendations and decisions for CMIP 7. We don't need a final decision now today. We're not like we vote on things, and it's more like a list of things that need to be done in order to figure out where we can be, right? Again, there isn't too much rush because CMIP is kind of all over the place at the moment, so it's not like we have a deadline, but I think every group and every breakout group and a lot of the talks gave us an idea about what to do. So more work that needs to be done in terms of, well, I'll have some example of that. Then we can have an outline. I will be in touch with the single task and people. And then what we can do is just for CMIP 6, the modeling protocol is not going to be super detailed, and then we can have more details on the GeoMIP website and on GitHub. And yeah, essentially the other goal, I think we talked about it last year as well, is for me, I think it's important is to get other models on board and to GeoMIP. The fast track is gonna help. But the idea is like this gateway drugs for getting people interested in SRM research, and I think it works. Yeah, I even took the time to, then I got bored. So, but in a way, prescription drugs are also a gateway drug to geoengineering. So, I think this is useful, and we are starting to see that, for instance, we have someone from Sokol, Iris. Sokol is starting to do some of the other experiments with the fast track. Probably we're going to be able to do that. And so if Shingo has now done work on this, so I'm very hopeful that we're going to be able to do more there. So in terms of recommendations, there seemed, and here, please raise your hand, say if I'm wrong. Also, the people online, somebody's monitoring the chat. So if you have anything you want to say, it seems that everybody was in agreement that since it's kind of pointless to suggest to redo G1. People are still using the CMIP5, and there's still going to be research done with those. But I don't think we need to replicate that experiment with CMIP7 models, or at least to suggest that. And the idea is essentially to shift the burden there to this G2 kind of experiment that we didn't do in CMIP6. And based on what Simone presented and what other people's feedback was, the idea would be to have a simple G2 SAI 1 degree of freedom, so just targeting global mean temperature, a G2 solar, so essentially the same one as it was before, and then an optional 3 degree of freedom with the controller that is going to be useful both as a comparison for then the fast track, but also on its own for science purpose. And if I'm correct, the 1% CO2 should be 50 years, but maybe it's 100. But we can also, I put here some rough numbers about the time constraint, but that's going to depend on what modelers want to do.
Originally, it was 50 years and then stop, and then 20 more years after that.
Okay, so they have 151% CO2. We don't need to we don't need to suggest that. So I can, Simone, how many years have you done?
So we did 150. I think that's what you did for 1% is 150 years. Do you hear me?
It didn't look. It didn't look from the plot that Simone you had done.
Oh. Well, Walker is there. He did
right.
The G2 SAI 3 DOF is 150 years.
Oh, okay.
1 DOF is intended to be 150 years, and we've done about 30.
Okay.
But I'm out of scratch space, so we gotta.
You can always move it in mind. But okay, so could be that actually this is 450. We might want to suggest that maybe we don't need. Like again, it's always a bargain between. Ben.
The fast track one, can you clarify 50x for me?
Oh, sorry, it's 50 years per member. What's the alternative interpretation of 50x? No? Yeah? What's up? Is it correct? Okay. Okay. Okay, so this would be 450 years. That's a big cell, but I think we can write in the paper that at least 50 years are necessary because that's the same length as the fast track one. And then, but if they want to go the full 150 years, they're welcome to. Then we have the fast track one. I know that Alan doesn't like because we already have a G7 Cirrus, but nobody, I mean, there's someone looking at G7 Cirrus, but in general, I think it's very useful to have G6 being from the CMIP6 version and G7 being from the CMIP7 version. And so we'll just pretend that G7 Cirrus never happened and deny that it ever did, I think. So I would call it this way.
But that's not going to happen for a few years because the models aren't there yet.
Yeah, but no, so this is just, but that's what we're going to call it. That's what the fast track calls it for the new version. Because the fast track technically is intended to be in the future. The fact that we have it already means that we already have ways to compare it. And maybe some models are going to be G6 1.5K SAI, which means that they use the CMIP6 version. The main difference here is that this is going to be prescribed concentrations. And then G7 is gonna be prescribed emissions because that's what CMIP wants. So that's gonna be sort of a few differences in terms of, I mean, there's gonna be differences.
That's what the fast track's gonna be, prescribed emissions.
They don't know yet. Probably will be just because they're not sure if the models can get there fast enough.
So in the paper describing this meeting, you're gonna have to explain all that.
Yes, yes.
So people don't get confused.
Yes. Ali?
Just a quick question, do you remind us of like the CO7 next FEC report timelines now, if that fits in?
Yeah, I mean, me reminding you of this is just, nobody knows. It changes every time so, okay. So this is it, right? Okay, it's useful actually to explain it to people, how does this work? So this is the experiment design for the fast track selection. So, you know, like everybody has in mind what experiments are gonna do, the one that are sort of high priority. But then essentially there's work that needs to be done sort of on the modeling side to get the historical forcing, the new ones, the scenarios proposal, then it needs to be run by the integrated assessment model. These need to be harmonized between past and future. And then these need to be fed into the models, the ESM runs, because you need to do all of this forcing testing. And so the idea is that by January 2027, there are the fast track runs done. This is 2 years and a half from now, but modeling centers are sort of saying that they're unlikely to be meeting these because this would mean a code freeze, as in the new version of the model needs to be like by July of 2024. And that's not happening yet because there's a lot of tuning to do, because once you move from prescribed concentration to prescribed emissions of CO2, then you need to get your carbon cycle right. In the meantime, we're doing all of the work about next generation diagnostics and variables. There's a new activity in CMIP about next generation diagnostics and all of that. Then eventually the fast track is the one that goes into GeoMIP and various downscaling things and blah, blah. So, and essentially all of this is because there is no timeline yet on the IPCC reports, but the hope, and here Ines can probably help me out, but the idea is that, I mean, they say that the synthesis report will be published by 2029, which means that all of the 3 working groups need to be published, which means that working group 1 needs to have a deadline for when the papers need to be submitted to be included in working group 1 that is around 2027. So essentially in 2026, if we're starting to have a few models with the fast track for GeoMIP, we need to get the papers out as fast as possible in order for them to be included into the IPCC working group 1 process. And then we have a bit more time for working group 2 and 3. There isn't yet a decision about how much SRM is going to be included. That's what the meeting in December is going to decide. There seemed to be some intention to have a chapter. We'll see. Or who's there? Pete? Yeah.
I guess I look at this, it seems like one of the big potential opportunities or missed opportunities, one of the big potential opportunities and missed opportunities is the GeoMIP 7 pipeline. Which if there's going to be people or funding to do that, we need to sort of arrange someone somewhere in the community should arrange that soonish. So that's ready, that pipeline's ready in time. So I think that could unlock a lot of extra effort from that community. So
yeah, so actually this is the point that Lily made, that maybe we can start contacting. I mean, you're already hiring contact and trying to figure that out a little bit better, how that can be done, writing proposals and getting the people moving. Yeah. Any other questions on these? This is very confusing. I know, it confuses everyone. But yeah. Okay. So if this is the timeline again, the idea would be then we have this fast track. Together with the fast track, essentially, especially for SAI, we need to have the single injection locations, simulations. We've done them already for UK SM1, CSM2, and GIS, which probably means they don't need to be repeated because they shouldn't change too much in terms of the training. But if you add more models, so these are useful to run. for a variety of reasons, because then we can use them for emulators, because then we can train a 3 degrees of freedom controller and all of these reasons. So my idea would be to sort of say, these are preparatory simulations. They're sort of the equivalent of a lot of tuning exercises that they do in the modeling centers, and to sort of, so not say that they are tier 1, but essentially strongly suggest that if you want to run some of these, you run at least some of these to get the tuning.
I don't know how realistic it is to expand the number of models that are doing these experiments too much. But you haven't mentioned anything about those models that don't have a good interactive aerosol, and how do we go about giving them specified aerosol fields?
Yeah, so that's been kind of, and Simone can comment on that if she wants, but it's been kind of an issue we've tried for CCMI. It turned out to be quite harder than we imagined. Though what Claudia has done shows that, yeah, at least in some models, it can be done kind of easily. And so, for instance, having a CAM version with prescribed aerosols could be good. It's kind of, it depends. So, and Andrin and the people at ETH have some code to generate the prescribed forcings. The G4SSA experiment that existed, and Simone had a description and Lily used it, wasn't then really widespread because models just like to use their own stuff. It's a bit complicated. I'll add some more on these, and maybe Simone will have the CCMI paper out by that point. We'll see how that goes. But for models that are kind of similar to CSM, so E3SM in some versions, CAM in others, you know, there could be that we can do it easily, and then for others we might come up with other versions, other solutions for this. Claudia?
I mean, I'm not sure whether it should be GeoMIP, but looking at very delayed SAI and irreversibility could maybe also be something to consider, maybe not as the next thing to do. Because especially if you also want to develop more into emulating stuff, there are some things that are like irreversible or non-linear, like for example, AMOC changes that you incur if you wait too long until you do SLM, and there could be more of that. So maybe that could also be something at least for testbed or similar to look at really late and massive use and irreversibility problems.
Yeah, so I'm always wary to demand more out of modeling centers, but this is why in the figures I had this one, right, that was essentially making the point that, you know, there's a tier one that everybody does, but then modeling centers are absolutely welcome to essentially spin up and you know, start from there and do other things, as in change the start date, change the target. Yes. Whether we want to mention that maybe as a tier 2 one, we can think about it. It could be a good idea. I don't know. Let's think about it. Anybody else has any thought on delayed? John?
Is anybody particularly simulating tipping points at all?
So yeah, there are 2 new MIPs. One of them is called tip MIP. And they even have a logo where the I is tipped, which is cringe. But anyway, yes, and there is another one. That now I cannot remember the name. They presented it at CSM. So essentially, a lot of European groups are doing these simulations of tipping points, and they have 2 different MIPs. The tip MIP that is what would it take to get to those tipping points, and this other one that is essentially what if we trigger those tipping points, how would the climate look like? These are all people who see SRM as anathema. All of these 2 MIPs are, I've found it very hard to connect to them. Like Valerie Masson-Delmotte is one of them. There's a lot of European groups that are really not that much into the whole SRM thing. But I don't know. Was that your question, or?
Yeah, because I think in terms of policy relevance and going back, sorry, the discussion this morning about it, that like when you look at all of these different SSPs, SSP3 is an awful lot worse in every way than SSB 5. And arguably SSB 3 is the pathway that we're going down, regional rivalry and all that kind of stuff. And of course, it also relates to the tipping points that once you're more likely to go over the edge, you've got less resources to go and deal with them and all that sort of possibilities there. So maybe it's not something to try and develop a scenario at this point, but maybe it's something we should be kind of thinking about in the longer term.
Yeah.
And because everything that delays any kind of action, of course, is more likely to be the other side of the tipping point.
Yeah, it's kind of hard because even those tipping MIPs, they acknowledge the fact that the ESMs don't have those tipping elements, and so they use other stuff like for AMOC. They are again at CSM they presented them. They had even big meetings. I think UKSM is involved in a lot of the AMOC, like hosing, like putting water to shut down the AMOC, all of that stuff. I don't know what the answer is there, honestly. I think we can just mention it and see. There's some papers coming out on like Amazon Dryback and whether SRM is a good way to prevent that as a tipping point. I mean, you have the no. There's another one then. There's there's your paper about collapse of ice shelves. So we can cite those and see maybe how things are represented in the new generation, but something specifically targeted on tipping points, I think that's hard.
We have some comments from the chat. I don't know if you discussed that because I just came back.
Yeah, they were, so Eva was saying, yes, I just saw them as well. Eva was saying that, yes, it does make sense to have them for at least 10 years. So the single injection, Eva was saying the single injection location, 10 years is fine. We wrote the papers on them. They're okay. 35 years is a lot better. And so this is a case where, if this is 1, 2, 3, 4, 5, 6, 7 times 10, it's 70 years. And I can ask for that. And then we can say, but please try to extend that for 25 more years, or maybe extend the ones you already have. So yeah, that was Eva's point. I don't know if there was something else. Simone said, oh yes, I think she was just.
And Simone.
Oh, okay, yeah.
And Simone says, I like the delay option with a realistic injection phasing, similar to what was presented for the Arctic. Not sure if that was discussed.
Yeah, okay, so I can add something here. Again, where there's a will, there's a way. So this would be useful for ozone assessments. Yeah, okay, at this point, if there's interest, we can talk Jim.
It's just something on high resolution. When we're doing the analysis of the impacts, like its physical impact or not, we frequently are taking something towards the end of the century. We can take the last couple of years at the end of the century, for example, and compare them against what might happen without SRM. So I do wonder whether there is a potential for us. I'm not saying that this can happen now, but I do want to give some thought to a time slice kind of experiment where you can run simulations just for the last 20 years or last 10 years with high resolution, much higher resolution models in order that we can really try and make things a little bit better for the impacts community and really look at differences between the high resolution really dynamic understanding.
When you start with an emulator, the first decade, would you start?
No, start.
Yeah, Claudia.
Just an example of what we are doing with our current run. So we are running a half-degree atmosphere, 10th-degree ocean simulation as a full scenario, but then at the end want a quarter-degree resolution in the atmosphere. So we do exactly as you say, run some really high resolutions from there. Well, the atmosphere is relatively feasible for the ocean, which has a much longer spin-up time. That's of course much more problematic. On the other hand, often the atmosphere is the more expensive part of the model. So maybe you could say you run the ocean at the target resolution from the start, and then run the atmosphere at the higher resolution for the last experience. So we want to run a small number of ensembles, like 5 or so, of 5 years each, so maybe 5 years in total.
There's also a protocol for DA-MIP, which is detection attribution MIP. Why do I know all of these MIPs? I don't know, don't ask me, but this one exists as well. And I think that this is more on the sort of earlier side to figure out whether you can do detection attribution of climate change impacts. And I think it uses some kind of different spin up that is with actually more realistic conditions. So, okay, but if the suggestion and the interest is in here, again, we can only suggest things, but finding a way, okay, last 20 years, okay, yeah. Does UKSM have a higher res? I mean, I know that you have a ultra res, right? Super high res.
Yeah. Exactly what we do with the ocean, I'm not quite sure. But I'm very interested because I do feel as though the impacts community is crying out for us, and yet we're sort of confined by the limitations of statistical downscaling rather than dynamical downscaling. There's big differences between the model responses, like different resolutions.
Are you suggesting more like global high res or regional refined, like regional modeling?
Global.
Yeah, because then it gets a mess to figure out how to drive that's what Ben has some expertise on. Maybe you can comment on that.
It strikes me that doing it globally is a lot easier because you already have the mechanisms in. Doing it regionally, we figured out how to do it. I'll let you know once we get results back.
So for the business of adding tier 2 simulations, I think let's call it low altitude SAI simulation. I think we've already got 3 groups.
That's the next slide.
Okay.
Now this is sort of, okay. So this was to say so this is G1, G2. Okay, we have this one, G7, with some tier 2 options and single injection location.
One quick thing.
Yeah.
Is it still worth calling it G2? Would G1% make more sense? Anyway, whatever.
No, because there's already the G2 old ones, and so I would keep it as G2 maybe. We're gonna save the word, maybe not. But yeah, okay, so the bipolar one, not gonna, no, we have to please find a way to call it somewhere else. But yeah, so this could be more of a test bed side, given everything, and maybe we don't even want every single model to do it. But yeah, as Ali was saying, so these exist. So the idea for this one in particular, for the other one, Simone has done this G2. We can help describe them. For the G7, we have the description, and Walker has done some analysis. For this one, this is really one of those where, Alice, you led you have the initial simulations, you've led the breakout group, so you could be one of the sort of contact points for this. And these are the things that need to be discussed for this, right? First of all, do we do it in both hemispheres or not? Is it gonna be a comparison with 1.5K? So to keep a temperature target, which means doing a lot of injection, but then we can compare it against the more even simulation, or is it gonna be what Lorraine presented, more towards a plausible deployment strategy? So you can't have it both way, even though you could have a tier 1 or tier 2, but you need to decide what's, anyway, like you need to work out these details. And then there's some work that needs to be done here. I think it's important about tropopause height in the different models. I mean, this is not going to end up in the GMD paper, but just to keep in mind.
What sort of plausible deployment?
Oh, what Wake had, what Lorraine showed, and Wake was talking about in terms of what would be feasible in terms of starting date and scaling up of the plane capabilities. you know, because if you do this, you're gonna have to do a ton more, and so, but I think I still think this could be, you know, do it if you think it's important, but it's a bit too, maybe I'm wrong, but it's a bit too
Scary.
arbitrary to have. I'm not sure. I'm not sure it's wise for GeoMIP to be commenting on plausibility of deployment, and yeah, that's my opinion. Okay, so this is good. Anybody has any comment on these? Doug?
Maybe this is something in a later slide, but I presume the process on some of this is that a few of us get together in some working groups and decide some of these things.
Yeah, this is essentially like, yeah, and I have some ideas about how to sort of do that in a way that is also not that is a bit more transparent. I'll say a few words on that, but yes, the idea is, you know, we get together, we come up with a simple protocol. Well, we explain that, we explain this in the GMD paper, and then you write a paper just describing the simulations, we have everything else, and blah, blah, okay? John? Oh, yeah, John?
Sorry,
sorry, I was like...
Shall I invite the person from the SAMI Council who is probably interested in being involved?
I mean, we have...
I think it would be a very good idea to do that.
We have... well, I don't know.
I think it would be a very good idea to at least inform and to say, are you interested in taking part in this formulation of the experiment?
Okay. I have to think. Well, again, it's like if John thinks it's so okay. Let's sort of list. So obvious positive side is, I mean, it would be fair to do. It's interesting. It would, but it's something that has never been done. As in, we come up with the GeoMIP experiments. Maybe we take feedback, but that is, you know, the analysis is sort of ethical, and it's something that comes post facto, and so this could be sort of just blocking it. But I don't know. Let's talk about this more. No, let's talk about this more, please. Yeah. Pete and Ben, probably, and
I think one of the members is, I think calling it, obviously not bipolar, but even calling it polar, I think is fair, because it gives the impression that this is a highly concentrated at the poles, whereas even, I think low altitude would be the better description, because it's really global in scope and have wide-ranging effects. And so privileging the Sami far northern community, they don't particularly have any extra say in this, I don't think. Unlike, say, for example, local sea ice modulation, where it's right in their neighborhood. This is, I mean, in the same way, why not have Amazonian representatives discussing G7, the main experiment? I think it's the same argument. This is, I think, classifying it as a polar is misleading. I think it's a low altitude injection strategy.
Yeah.
I would say high lat, actually.
Yeah, it's very high latitude,
Yeah, but that's because you have to, that's the only place you can get up with a low altitude injection.
But if you call it low altitude, that looks like you're trying to cover up something.
Why?
It's suspicious.
Yeah.
It sounds like it's the troposphere that you're doing.
Yeah.
Well, I mean, okay, well, it's lower stratosphere, okay.
Can I personally veto low altitude?
Yeah,
Okay.
you
The person here who gets death threats.
Well,
Chemtrails. Oh, let's call it chemtrails. You go. Andrew.
Yeah.
Oh, sorry, Ben first.
So, I don't particularly have any reverence for how we come up with GeoMIP experiments. I mean, going back to the beginning, we just kind of talked about them, and there they were, and suddenly that's setting how this community thinks for years. So I'm interested in doing it better. If John's contact in the Sami Council wants to be an honest participant, I think that's reasonable. I mean, if we are, as a community, serious about transparency and informed consent and co-production, I think we should take this seriously.
So thinking about it a second, I want to say my yes, but is having worked on the AGU ethical principles, we've had a lot of discussions over many things, but one in particular was who is impacted, if we agree that impacted communities need to be involved in the co-design, what constitutes impact? And there were some of the people in that room that had a very broad definition of who is impacted up to, and that word is still there, and I hope still working on getting it out, sort of like who is spiritually impacted or ethically impacted by a specific, which is essentially everyone in the world. So if the Sami, why not the Canadian indigenous population? Because the Canadian government is technically forced to right, or why not? You know, if this impacts precipitation in Argentina, why not the? I don't know. This is a tough problem, and definitely one we can discuss in terms of co-production. I don't know. This is hard. I don't know, Jared.
I could have some replies to that.
Yeah.
So of course, one of the reasons that we would want to maybe include them is the small group of governments that is the Arctic 8 plus the 5 indigenous communities. The Sami Council are one of the people that send delegates to the Arctic Council, and they are very closely linked with the other 4 indigenous communities. So when I say a representative from the Sami Council, it is essentially also a representative of the Arctic indigenous community.
Okay.
So I think that we don't need to find 50 others from every community.
Okay. Alistair, and sorry, Andrew was first.
So this isn't a question for me. I'm channeling my inner David because he's not here. So he was very, very concerned about the need for chemistry climate modeling on this on these polar scenarios because of the limited conversion of injected material into aerosols and resulting impacts on toxicity. So you might have to put a lot of material in to get the number of aerosols that you need. So I don't have the knowledge to understand whether that's a valid concern or not, but I didn't want David's what's likely a very important point to not be brought to the audience.
Yeah, that's why I wrote stratospheric pathways from analysis CDMs. We can definitely think about that second more.
I guess I just wanted to echo Ben's point really that we are somewhat arbitrarily writing down scenarios that then do have really large power and like the decision you make do live on for a long time and it doesn't matter. So I really do take John's point about co-production scenarios, and it would be great to get more voices. It feels like perhaps the degrees global forum being in the same place as GeoMIP next year might be a good opportunity to do some of that. And I don't think it is unique to G7 polar or whatever we call it. It's true of all these scenarios, they all impact everyone. There is nothing really special about having more low altitude, high altitude injection in terms of who has to have a voice in that. It has to be the whole world, all the scenarios, right? But perhaps there's a way to do some of those exercises productively next May in Cape Town.
Yeah, that maybe. And maybe if we, okay, this is a great discussion. You know, in a way, we're also pretty representative in this room in the sense that we do have people from all over the world studying these. Okay, let's keep this discussion going. We're not going to find a solution, but I think it's great that it was brought up. And we can, okay. Yeah, that's good. Laurie, yeah.
Just to add to what Andrew said, it wasn't just the stratospheric pathways from the analysis that David was advocating for in the scenario. It was injection scenarios that include multiple altitudes to to make sure that you get the lower altitude.
That's correct.
Yeah, that's okay. Maybe it was just I was just unclear. That's what I meant. It's sort of like using something like Hongwei Lagrangian model, different injection location. Maybe it's something that is also reanalysis based to figure that part out. So before deciding on an altitude, doing some of the work that Alistair has already. Yeah, that's what you meant. No, even something different. Sorry if I'm misunderstanding.
Not before deciding on an altitude, just picking 2 altitudes when you run the Earth system model simulation. So that you have the impacts from rain.
I hear you, but that's what I'm saying. It's sort of like I would first try to find a way to figure out how do the tropopause height from reanalysis compare to different models. And so, because if you keep two different altitudes, but the circulation is different, is that what we want, or do we want something that looks closely to what reanalysis would be like? I don't know. Let's try to figure. I hear you now. Okay, yeah. Let's lots of discussions to have in this part, but okay, yeah. Yeah, John.
One of the important things might be to ensure that we have a list of variables that are going to be kept. And maybe it's important to also ensure that we have higher frequency data stored as well from such a scenario like this. Because of course there will be these impacts like David talked about between 2.5 and stuff like that. So we probably need to store a whole bunch of extra variables that maybe we wouldn't necessarily assume to be important.
Yeah, so that part is going to happen through the CMIP study, and then there's a follow-up on atmosphere. Like there are, yes, but probably we need to have, this list being explicit. I did a bit that in the G6 1.51 with some list of things, but yeah, okay, good point. There are questions in the chat that I'm not sure that I'm following super well. There's anything that I need to repeat for the.
Yes, just I think repeating what we did in the after the breakout discussion about.
Yeah, so additional output is essentially what I'm gonna have to figure out is whether there's gonna be already the products that tell people just use this set of variables that you need to save, as opposed to me having a gigantic list in the supplementary with all the things. So we'll see that, but yes, especially with EasyMIP, we'll try to figure out better what are the variables that are absolutely needed. That's gonna bring a question about where do we store that, because if this is not gonna happen on the Earth system grid until later, and that brings back questions about data. Yeah.
Yeah, as these sort of, okay, so I'll start with saying, not everything is rational. So you will get people who are looking at things like no altitude experiments, and you can do this when you just look at things. And seriously, I know people say, G7 chemtrail, but I've had over 420,000 views of something that I did 12 years ago on YouTube, and it has got quite personal. So there's been various different death threats that arrive by letter, so that you don't know who they're from. It's not by email. So do be aware of what you're looking at. It's not up to you this. And I do think that the GeoMIP website could really do with something where we say that we're not necessarily endorsing geoengineering. We're doing this as the most objective thing.
It says that in both landing pages.
It doesn't.
There's one that it does.
Okay, I'm just looking at it now.
But also say chemtrails don't exist.
I mean, it's just I think we need to have something that's very clear, and it would help us if you're going to go forward with low altitude kind of experiments. You really want something that's covering people and making sure that they're not likely to get, or the whole thing is not likely to get attacked by non-rational people. So I think that needs to be strengthened.
Yeah.
And I think that if you're going to go for this, you really do need something like that.
Okay.
It's not nice. A lot of
now they get them through the WCRP, so that should be the lightning rod for everything. No, but if you want to suggest a rewarding, let me know. And yeah.
You're on the advisory committee.
Yeah, but in general, anyone that thinks that there should be a rewarding, and then okay, but that's a fair point. Okay, I don't know how to write this in the slide, but yeah, no.
Can I just read what we say?
Yeah.
This project does not endorse or advocate either testing or actual implementation of geoengineering. It also does not attempt to dictate climate policy of any kind or task which we feel is best left to governing entities. Our purpose here is to study and inform.
Do you think it should be moved up, so it's not at the very bottom?
Yeah.
The page isn't very big. Yeah, you could do that certainly.
I think the confusion is because
It's not on the GeoMIP about.
no, it's not on the about. It's the page that says GeoMIP. It's like the landing page if you write Rutgers, blah blah blah. But okay, but I probably need to refigure this out.
I wrote that in 2010. I don't know. Make it better.
Yeah.
That was good.
Yeah, I think it was good, and I think Piero wanted to say something.
Yeah, about the 1.5K, 1.5K versus possible deployment. I think probably I'm imagining from a climate standpoint, a comparison standpoint, 1.5K is better. But at the same time, it should be made as such that you would be able to compare the short term and the long term. Because of course, if you do only polar in the long term and try to keep it to 1.5K with underlying RCP 4.5, it's going to look, I would assume, way worse than tropical deployment. But at the same time, if the idea of polar deployment is like a bridge, as long as you don't have the technology to go real atmospheric, I think it would be important in the design of the experiment to be able to look at 2030, 2039, which is maybe the most interesting.
I'm gonna show a figure from the paper with Jan just to make you want me to?
Sure.
It's
It's a G6 1.0K.
What figure is that, Doug? 8?
Well, figure 8 is the residual relative to reference with about 1.4 degrees of cooling.
I mean, it
So yes,
doesn't
you
look
get more
great, but
cooling at high latitudes.
awful.
but-
Yeah, does that I mean, yeah, this is a lot more cooling that would be under one. I mean, it's alpha degree more cooling, so it looks different. And again, it could be that different models is gonna look different. I don't know, Matthew, did you have a 60-60 as well?
Yes.
Did it look vaguely like this or?
Yeah, it's more.
Okay. Okay, I mean, these are things, I mean, eventually, maybe we should just call this 60-60, so it's just a bit less contentious. Okay. These are all noted points. They will make it into the discussion for the report for the meeting. I'm not gonna write the word chemtrail, but yeah, noted. Okay, so moving on. The MCB one, sort of the same thing. Haruki, Matthew, and Jim, and other people are doing a lot of amazing work. We're clearly not there yet. We might have to eventually, by the time we need to write this, we could be at a different place. We need single regions forcing, which is what already exists in 3 models. How many regions? What are the best regions we're going to suggest? This is all, again, you already have essentially your breakout group on these. So anything that would be useful on the GeoMIP side, we can be in touch. How to combine them? There is this thing that I think maybe if Walker or somebody with CSM could do in terms of comparing CDNC, so an increase in cloud droplets, actual injections of sea salt and ERF, in order to be able to tell models that maybe don't have CDNC or sea salt what they should do in terms of ERF. So a comparison, even just one region, to get 1 watt per square meter in a region, how much sea salt, how much CDNC, and sort of a discussion like that to allow models that are maybe simpler to do this as well. How many years you need to do the single region forcing. This one as well for the diagnostics, that's what Jim suggested. Yes, okay, I'm talking to our GeoMIP already. And then links with the cloud forcing MIP and regional aerosol MIP to figure out whether we can leverage those as well, maybe for some other reasons. Any comment on MCB on this? That's smooth, just because that's what's which one's MCB again? Jim? You have something you wanna?
It's G6.
Oh yeah, at this point it's G6. It's whatever it is, yeah. Okay. Anything else on these? No, we're fine. Oh, and what are you currently doing for the CECL ones? You're prescribing the size distribution?
Yeah.
And these are all models, so you can just, is this in 8can or accumulation or?
Okay, so I guess I can make two comments. The first
Yeah.
is that we have compared sea salt and C and C. That's in Phil's protocol paper.
Okay.
It's buried in the supplements.
Okay, I didn't read that.
And the other thing is, right, I mean, this is something that we'll probably have to discuss among ourselves in the groups, is that, yeah, I mean, exactly how to describe the sea salt emissions is something that we're currently essentially using the most ideal possible distribution, so it's very narrow on this source. And so that maybe that's giving us a unrealistic idea from mass emissions we actually need, but you know, also that's a nice way to achieve it, at least in the simulation.
Mm-hmm. Yeah, and for these, I was saying mostly because when we did the test bed for H2SO4, we spent some time to figure out what to do with sectional aerosol models in case they wanted to contribute compared to model. There are a few differences, so yeah, and now CSM has a Karma version that maybe can be included down the line, even though it's very expensive. Okay, so this seems like you all know the work that you need to do on these, and this is sort of just more of a how do we integrate this with GeoMIP a bit, but you're doing already all the work that you're doing. Okay. Okay, so the other thing that this is sort of connected. Last year I did make the GitHub for GeoMIP. Nobody's using it except me, but that's okay. But you know, this could be. Oh, you stole the picture that I stole from. I don't remember, but I clearly don't have the permission for that. Yeah, so what I did is that I did put some shareable code, which is my way to analyze GeoMIP data. There's the announcements for the papers that are published through GeoMIP, the meeting report and all of that. This could be a place where essentially you just ask me, I make you like whatever the name is for being part of the repository. You can create your projects or discussions. You can have repository for code. So I think this is and the other thing that I want to do is to add the web pages for GeoMIP here. So if you want to have you want to push the update for your own paper, instead of asking me to add it, you can do that. If you want to have the new page about emulators, once I put it up, you can do that. So having the GitHub, because now a lot of MIPs are starting to do this, just need some help and assistance on this, but you know, these exist, so there could be discussion. So maybe you want to have at least the announcement that, you know, you have the Polar one, you meet, you know, this is what came out of it. This is all in the interest of transparency. There is a big push right now, and then eventually down the line we can have code, Jupyter notebooks for analysis, and so on and so forth. These, of course, doesn't include sharing data, because sharing data is a different thing, and GitHub doesn't let you share anything. I mean, it's not a data repository. So that's sort of the other question, and sort of this is more on the sort of money side, but hey, let's talk money in the sense of, I think this is important, right? And it's unlikely that we're gonna have everything on the Earth system grid anytime soon. So it would be good to start sharing data. And if we want sub daily, that's a lot of effort. If anybody has any idea, I talked a little bit about this with Claudia. QCF is aware of these needs. I talked to them a bit. You know, this is something that on it like needs just money, right? Like needs a dedicated data person. Other projects can have the support of NASA. I don't think NASA is going to help you here, but you know, finding ways. For now, one of the ways we sort of patch these up is through Anchor and the Anchor supercomputers and giving access to Global South researchers to the Anchor supercomputer because it's actually cheap and easy, but Anchor doesn't have infinite storage. And especially as we move into CMIP 7, they're not going to do that. For now, we store stuff on Globus, which is very easy to share then, but you know, just be aware of these. And if anybody has any idea or interest or things, I think that next year in Cape Town, I'd like to have a session on these and would like to have made some progress on these. So yeah, this is more of a wish list item, but Lorraine, yeah. Ilaria is gonna be sooner than me.
Would it be possible to, I know we can't store data on GitHub, but maybe have links to where the different data for different experiments are stored for different models?
Yeah, that was Claudia's suggestion. Yes. So we already have on the GeoMIP website, there's a spreadsheet with all the models, with all the resolutions, all the contact points, and all the simulations that they've done. Again, I only have a limited amount of time. So if anybody knows that there's something like, you know, yes, I'm gonna try to do this, we can do this at Cornell. So that could be a good starting point on the GitHub of like where to find data. The other question is for those on the impact side. If you have a question, yeah, send me an email, it's fine. But if you can also post it on the here, sort of we have a FAQ on the discussion, you know, because normally the problems are always kind of the same. So having a place where people can search it like the CSN forum does, I think it's useful. I think I saw a few hands. So John, Claudia, and Pete.
So the sort of big problem in much of the global south, as far as I take it, is that you've got such slow download speeds. So is there really, I mean, why not just carry on doing like we've done before, put it on a load of hard disks, and sure, it takes a lot of time, so we can pay somebody to just store a shitload of data and take a bunch of tapes, or, you know, in the old days, tapes.
Yeah.
Back that down to the next time we all need to go and have.
Yes, that's what I do normally at degrees meetings. And Claudia made a point that I think it's very fair, which is that sort of there's a gatekeeping aspect of I cannot put every single experiment, and so having something where people can pick or choose more freely is something that would give me a lot less heartburn in terms of, you know, I don't want to pretend like I'm the one deciding for impact teams what they need to download. And so having something like this, but you know, what we try to do is that Ilaria made some Jupyter code for Jupyter Notebook code to extract variables. So when the teams ask me, I don't tell them to download the whole thing, but just a section of that, a single layer. So that's what I would like to see. So then, you know, if somebody has better ideas about cloud versus supercomputing, whatever, but yeah, that's where we should be going. So Claudia, and then.
So for the Excel sheet you mentioned, it has only the actual GeoMIP experiments, or it has also other experiments that are like geoengineering stuff, but not officially GeoMIP?
No, for now it has only GeoMIP. So I want to make yeah, that's the point. Yeah. Anyone, once it's on GitHub, is a bit better than through a spreadsheet. Pete, and then Cheryl. I'll come back.
Quick thought, I mean, I think it was Cheryl's idea from earlier of working groups. Does it make sense to have a data working group as well as the experimental working group, just to sort of, so it's not all falling on the Danielle work?
That's why I want to have the GitHub, right? Is so that people can just volunteer, they can participate. Yes, that's the thing. Yes. Cheryl.
Noah has a saying that a software that's open source called a data access portal that was invented just for this, where it interfaces with NetCDF files and you can subset them and make maps and download it in different ways. So if you can get that as a layer on top of wherever the files are stored, it can make it so you're not pushing as much data if you're trying to do it with the internet, and that can increase access for people with limited bandwidth. Like if you just care about Somalia, like you don't need to download the whole planet, right? Like.
That's next on the list, Alex. Don't worry.
Yeah, picking up on that, so OpenDAP's kind of a heavy lift, but Pangeo is out there. I think this might have been Lauren's idea, or I heard it somewhere, that, we could figure out how to make GeoMIP output available through that, and it's server side, and so you do all the analysis there and you pull what you need.
Yeah.
Yeah.
I mean, I've looked a lot into how Pangeo gets funding and everything. That's Goodwill. So if anybody knows anyone at Google.
I'll send you a working group, and I'd be happy to be part of that.
Okay.
Yeah, and like, I don't know if I want to lead it, but I would co-lead it with somebody.
It's not working anymore. I think this is that.
Yeah.
Is that?
The only one.
Okay.
Well, look at those lapel, those.
I'm not gonna wear one. No, yeah, okay. Maybe you can just go around with these.
With these?
Yeah, whatever.
Why don't you want to wear these?
I don't have these pants. They ruined the line of the pants. That's the reason. That's the honest reason. So yeah, this was on the chat. The other point was sort of and there was some discussion yesterday about some repository of papers. The one that I have on the GeoMIP website is only for GeoMIP. Is this on? Okay, now it's on. The repository that I have is only for GeoMIP papers. I'll send everyone the link, or people here on the room can maybe see that. So they have these, Alex and the people at Silver Lining had this list of papers with some metadata. They have, you can check it out. I'll send it to everyone. Yeah, there's sort of a list of papers. There's some criteria for inclusion, so they don't include everything. There's impact paper, modeling experiment papers, so you can see them here. They're searchable. Yeah, there's a lot of metadata, and so I sort of had this idea similar to this, but sort of never done it. But like with a map or something where you can essentially do the same thing, so this could be great. The only issue that I'm gonna mention is, which is always the same one, is once you come up with criteria, you're excluding something and including something else. For GeoMIP, it's easy because it's just like that's what's with GeoMIP results. So let's figure it out. Alex, I know you're in the chat, so I'll send it around to everyone, and then people can take a look and send you feedback. What is all good? Okay. I'm just gonna go through a very few last things. Okay, yeah. Well, statistical downscaling, we talked about high res. These eventually need to be added to the repository. I think that whatever we're gonna do with high res, having a benchmark that is statistical downscaling, just like the CMIP 6 one that it was done by NASA, would be cool. Again, there is this thing with ERA 5 at 1/4 degree resolution, all on the cloud with one line. You can download anything you want. Finding a way to do that would be great, and then compare with bias correcting or the statistical downscaling using measurement, because we know that reanalyses are not good, for instance, for precipitation in many places. We have lots of people here at Cornell that do that, and so if they hear that you're using ERA 5 for precipitation reanalysis, they get a heart attack. So probably, but at least it's good to know, right? I wouldn't necessarily think that that's the perfect way, but it's good for benchmarking. Same for dynamical downscaling. Ben is working on this a bit. Chris, as mentioned, day one. Where's Chris? There. But on this sort of Cortex connection and figuring out what we can do there. Again, this is going to be a massive amount of data. I have no clue where we would put these data. So this sort of goes back to the previous point. Any other comments on this? Yeah, the last thing, just to sort of go back, this is sort of a to-do list. So I have it in slide form and I can remember. So I'm gonna try to have a page collecting info. Maybe we can have it on GitHub. We can discuss what to write there. Essentially, I would like to do it on GitHub because it's easier to update who's doing what, and everybody can sort of volunteer, hey, I'm doing this, because it's very useful. And as Claudia mentioned, you know, there are different things we mean by emulators. And so I think will be useful. And there's a white paper that Claudia is leading as well. So there will be a lot there. Maybe eventually make it into a repository so that people can share code and blah, blah. And then, I mean, there's not going to be GeoMIP, but we should think about a meeting about emulators that includes also the impact side. Okay. I don't know. There was a last point that we had last year as well. Anybody feels like they want to volunteer, say something, or complain about something, or challenge me and Alan to a duel to get the co-chair? I have swords at home. Shoot, want to know? But so if there's anything here or anybody else has anything to say or that I forgot to mention and that we could, yeah, Doug.
Just a question of whether there's any other modeling groups that are planning on G6 1.5K. And subsequent to that, potentially there's some group of people who might want to make sure they're coordinating the papers that get written off of those.
Yeah, Wilker.
I'm aware of 3.
Well, you analyze 3. Yeah.
Well, no, I'm aware of 3 more.
Okay.
That either I or Shingo have spoken to. Just that E3SM, it's on their very long to-do list. And Shingo has spoken to representatives from ITSOL and one other one starts with an S. Sokol.
Oh yeah, Sokol. Yeah, Sokol. I've been talking to them. I do have, as part of the QCF funding for GeoMIP, there was sort of some time for a postdoc to sort of do this coordination. So first of all, if you're looking for a postdoc, you can come here at Cornell. But second of all, also we have that, so we can work it out. If you feel like your model could do this, but you don't have the capacity, we can help. Like we've been helping Shingo and everything else. Walker has done a lot of work. My personal experience for G6, the other G6, was that when we had the meeting in Beijing in 2018, I sort of volunteered to lead the first G6 paper, and there was only one model, and I wrote the code to make it expandable for everything, and sort of I had all the plots with one model, and then as model was coming in, I updated it, and then when I had 6, I was like, okay, 6 looks fine, and then just finish the paper. So that's a good way. Yeah, if you want to volunteer for specific analysis, there's a long, again, think about this. My suggestion is also think about this for what would you like, what analysis would we like to see, or would you like to see in an IPCC report that mentions SRM? And so if you think that there's something high impact that you want to do, we had, I think, Ben, was there like a spreadsheet with people tracking what they were doing, or was that for plans? Maybe that was for plans. You know, email, like, you know,
Poorly updated spreadsheet, yeah.
yeah, if you email, it's not because you don't have to volunteer, maybe you're not gonna do it, but it's useful to know people are not duplicating efforts. It's useful to know you can get help. So, you know, we're a community, let's act like and I think we can get a lot of work done in the next 2 years.
I like the idea of a spreadsheet. Since giving my talk a few days ago, several people have come up to me and asked if they could be involved.
Okay.
And I wasn't really sure how to answer that because I've sort of been the informal point of contact up until now, because I've been helping people set up the feedback algorithm. But in terms of actually writing papers, I like that idea.
Okay, let's
some kind of Google Doc
or GitHub, which is, I mean, just because GitHub, we don't have to worry about permissions and stuff. So you can post, so you can have a discussion there. If you email, if anybody's interested, they email me, I can give you GitHub access. And so we can do that. Okay, so that's great. That's a new way. Alice is volunteering for 5 papers.
Oh, sorry.
Oh,
that's
yeah.
Sorry, is there a participant list available for this particular meeting?
Oh, that's actually something you can tell me. Well, actually, once I forgot to put everyone in BCC, and so everybody ended up in CC, and so you might have it somewhere. What's the best way? Do you feel comfortable? Is there anybody that doesn't feel comfortable sharing their email with the attendees? Like technically we're like over 100 people, so.
People aren't here though, so you need to send out like a.
I mean, to me, the best thing is still like the GitHub, because you say, I wanna be here, because then mailing list get, or there's the GeoMIP. So the people who are at the meeting are the people who would participate to the meeting, but we have the GeoMIP mailing list. Do sign up. If you go to the GeoMIP website, there are instructions about how to sign up. Do sign up, and if you have, normally now people, I send emails, a few other people send emails about events, but you can also use it to say, hey, I just published this paper, or hey, I'm looking for help on this particular thing. We've never abused it, so I think it's fine. So again, use the GitHub, but also use the mailing list if you want for a specific thing. Alice?
I guess that was actually kind of what I was gonna ask is the GitHub a place where we can have like community discussion? Because I feel like a Slack group or a Teams group, whatever is, there are so many different things. If that's something you can do on the GitHub, it would be useful to have like a community discussion page.
Yeah, so this was the idea, right? As in here, you can have discussions, you can have announcement, general ideas, polls, Q&A, show and tell. Then you can have repositories. You can technically make projects. If you have a degree in computer science, you can understand how to do these. I don't, not yet. I think there's see people, yeah, you see some of you are already here. It's not that you use it, but yeah, that's all the members that volunteered last year to actually be added. But
If that was like a thing, if everyone signed up on it.
Yeah.
Like everyone in this room actually did that.
Yeah.
And then we could actually talk about, oh, I'm doing this project and who can help me?
Yeah, I did send an email last year saying you should sign up. Nobody did. As in you and Matthew did. Yeah. Oh, but I don't have holidays. That's the misunderstanding, Claudia. But I never take holidays. But no, okay. Once we send the report, at least the link is even in the report. So okay, if people can do that, yes. Let's on a Slack. Oh God, there are so many. No, I would veto another Slack.
And also make it private if you want, and then release only the things you want to release.
I don't remember if I set it to public, but I think so because I wanted to have the shareable code. No, it's public. I think I want to keep it public. We're not hiding anything. I mean, or if we are, I'm obviously not telling you now, but okay. Any other on this? Anything else on this? We have 3 minutes. Come on, let's close it 30 precise. No, otherwise we can just close it now. Oh, who? Oh, sorry, Ben.
So having done a few of these before, I know how much work goes into it. So could we have a round of applause?
No, I hate that.
Thank you.
And the students too.
Yeah, no, I already think that and Anne-Marie's like the secretary was amazing, and then Ilaria, Ezra, and Jared actually did a lot of the actual work of like bringing coffee and stuff. So thank you a lot for. Thank you. Okay, cool. See you. Have a good travel back. I hope you don't get too delayed. You'll hear from me. Thank you to all who joined online.
So Dan, how do we get to the GeoMIP GitHub?
Where is sharing? Thank you all online. Much appreciated.
Thank you.